Hello, I'm Brian Farrell, and welcome to PACE IT's session on the Introduction to Network Devices, Part 1. Today we're going to be talking about the Open System Interconnection Model, and then we're going to conclude with a brief discussion on some basic network devices. There's a fair amount of ground to cover, but not a whole lot of time, so let's go ahead and begin this session. Of course, I'm going to begin by talking about the Open Systems Interconnection Model. The Open Systems Interconnection Model, or the OSI model, was developed as a way to help disparate computing systems communicate with each other. It created a layered approach, a 7-layer approach to networking. This layered approach not only allows those disparate systems to communicate with each other, but it has the added benefit of helping to create a secure networking environment as well. Security can be placed at the various levels of the OSI model to create a layered security arrangement that will vastly improve the security of an overall network. Knowing networking devices and where they fit into the reference model will help the security engineer to create a more safe, secure, and efficient network. With that covered, let's move on to basic network devices. A switch utilizes an application-specific integrated circuit chip, or an ASIC chip, and it is considered a Layer 2 OSI device. The ASIC chip has specific programming that allows the switch to learn when a device is on the network and which port that device is connected to via that device's Layer 2 MAC address. Managed switches allow for security to be placed on the individual switch ports, creating a more secure networking environment. One caveat with switches, though: a switch will only communicate with local network devices. That means it cannot communicate with remote networks. Then there is the wireless access point, or the WAP. A WAP is a specific type of network bridge that connects or bridges a wireless network segment with a wired network segment. And it is also considered a Layer 2 OSI device. The most common type of WAP bridges an 802.11 wireless network with an 802.3 Ethernet network segment. All wireless access points are capable of utilizing encryption to help ensure a secure networking environment. And because they have that capability, you should ensure that all of your WAPs have encryption enabled. A WAP will also only communicate with local network devices, unless, of course, it's a wireless router. But that's a discussion for a different day. Then we have the multi-layer switch, or the MLS. An MLS provides normal Layer 2 network switching services, but it will also provide Layer 3 or higher OSI model services. The most common MLS is called a Layer 3 switch. It not only utilizes an ASIC chip for switching, but that ASIC chip is also programmed to handle routing functions. This allows the device to communicate and pass data to non-local network devices. The MLS commonly implements security at Layer 2 and higher of the OSI model. MLSs are not very common in small networks due to their expense. Then we have the router. The router is the most common network device for connecting different networks together utilizing the OSI model's Layer 3 logical network information. Unlike the switch, which uses an ASIC chip, the router uses software programming for decision making. Firewalls and access control lists are commonly placed on routers to help secure networks. Speaking about firewalls, a firewall can be placed on routers or hosts. This would mean that it would be software-based, or a firewall can be its own device. Usually in that case, it's a network appliance. Firewalls function at multiple layers of the OSI model. Usually you will find them operating at layers 2, 3, 4, and 7. Firewalls block packets from entering or leaving the network, and it can do this through one of two methods. It can use stateless inspection. That's where the firewall will examine every packet against a set of rules. Once the packet matches a rule, the rule is enforced and the specified action is taken. The other method that a firewall can use is stateful inspection. The firewall will only examine the state of the connection between networks. Specifically, when a connection is made from an internal network to an external network, the firewall will not examine any packets that are returning from the external connection. As a general rule, external connections are not allowed to be initiated with the internal network. In other words, a firewall that uses stateful inspection will only allow connections to be made from inside to outside. It will not allow that outside entity to initiate a connection with an inside host. Firewalls are usually the first line of defense in protecting the internal network from outside threats. You can consider the firewall as the police force of the network. Then we have load balancers. A load balancer may also be called a content switch or content filter. Load balancers can be implemented to increase the security of a network by limiting or filtering the content that is allowed to be on the network. A load balancer can be a network appliance that is used to load balance between multiple hosts that contain the same data. That means that they will be spreading out the workload for greater efficiency. Load balancers are commonly used to distribute requests to a server farm among the various servers, helping to ensure that no single server gets overloaded. Last up, we have the proxy server. A proxy server is an appliance that requests resources on behalf of client machines. It's often used to retrieve resources from outside untrusted networks on behalf of the requesting client. A proxy server hides and protects the requesting client. That outside network never gets to see the internal client. Proxy servers can also be utilized to filter allowed content. And finally, a proxy server can also increase network performance by caching or saving commonly requested web pages. That concludes this session on the Introduction to Network Devices Part 1. I talked about the open systems interconnection model, and then I had a brief discussion on some basic network devices. On behalf of PACE IT, thank you for watching this session, and I hope you watch another one soon. Good day, I'm Brian Farrell, and welcome to PACE IT's session on the Introduction to Network Devices Part 2. Today I'm going to begin with an introduction to the layered security concept, and then I'm going to conclude with a brief discussion on some network devices. There's a fair amount of ground to cover, so let's go ahead and begin this session. I'm going to begin by introducing the layered security concept. Modern networks are composed of multiple layers of devices and applications, which can lead to issues with security. The more layers you have, it's possible the more vulnerabilities that are present. So while this does make the issue of security more complex, it also has the added benefit of supporting the concept of a layered security approach, which could also be called security in depth or defense in depth. Each layer or device can contain its own security methods. This means that if a breach occurs in one area of the network, the rest of the network will remain secure, at least hopefully. It is a best practice to use a layered approach when implementing network security. Many security devices are triggered by a specific action occurring, as in a network packet crosses an interface on a router. This creates a situation in which those devices are only capable of reacting to perceived threats. That in itself can be a weakness in security. On the other hand, some devices are capable of application awareness. This feature allows security devices to make better decisions based on which applications are allowed to operate on the network and which applications are not allowed to cross through it. This is another layer that can be added to the network's security. Some devices that may be application aware include firewalls, proxy servers, and network intrusion detection systems or network intrusion prevention systems. With that, let's move on to some network devices. So we're going to begin by talking about the VPN concentrator. A virtual private network concentrator, or VPN concentrator, will facilitate multiple secure VPN connections to a network. The type of incoming VPN connection to the network will determine what tunneling and encryption the VPN concentrator will implement. Most concentrators can function at multiple layers of the OSI model, specifically at layers 2, 3, and 7. Outside of an internet transaction, most concentrators will function at the network layer, or layer 3 of the OSI model, providing IPsec encryption through a secure tunnel. Let's discuss network intrusion detection systems, or NIDS. A NIDS is a passive system designed to identify when a network breach or an attack against the network is occurring. They're usually designed to inform a network administrator when a breach or attack has occurred, and it can do this through log files, text messages, voicemails, and/or an email notification. A NIDS cannot prevent or stop a breach or an attack on its own, as it's only passive in nature. It receives a copy of all traffic and evaluates it against a set of standards. That standard may be signature-based, which means that it evaluates network traffic for known malware or attack signatures. That standard may be anomaly-based, which means that it evaluates network traffic for suspicious changes. It could be policy-based, which means that it evaluates network traffic against a specific declared security policy. Finally, it may be heuristic-based, which means that it evaluates network traffic against past network behavior, which means that it's looking for changes in expected patterns. Now, the intrusion detection system may be deployed at the host level as well. When it's placed on a host, instead of being called a NIDS, it's called a HIDS. Then there's the Network-Based Intrusion Prevention System, or NIPS. A NIPS is an active system designed to stop a breach or an attack from succeeding in damaging the network. They're usually designed to perform an action or set of actions to stop the malicious activity. Just like the NIDS, the NIPS will inform a network administrator through the use of log files, text messages, voicemail, and/or through email notifications. All traffic on the network system is required to flow through the NIPS to either enter or leave the segment. Like the NIDS, all traffic is evaluated against a set of standards, and the NIPS uses the same standards as the NIDS. The best placement on the network is between a router, which hopefully has a firewall, and the destination network segment. The NIPS is programmed to make an active response to the situation. Some of those responses could include to block the offending IP address. It can close down the vulnerable interface. In some cases, it may terminate the network session. In more advanced systems, it may redirect the attack to a honeynet. There are additional actions that it can perform. It all depends upon how the NIPS is programmed. Then there's the Unified Threat Management Security Appliance, or the UTM Security Appliance. It is a possible all-in-one security solution. It may contain firewall features, it may contain IDS features, or intrusion detection system features. It can contain antivirus and anti-malware features. Your UTM may also have anti-spam features. It can perform content and URL filtering. So it all depends upon what kind of UTM that you purchase. You can get all of those features into one package, usually in the form of a network appliance. A network appliance is a specifically designed piece of hardware with an integrated software package, thus creating a closed system. The positive aspects of the UTM include that it provides multiple security features in a central location, which simplifies the management of security and eases updating that same security. A negative aspect is that it can concentrate security into a single system or location, which can create a single point of failure for both the network and for security. Now that concludes this session on the Introduction to Network Devices Part 2. I began by introducing the layered security concept, and I concluded with a brief discussion on some network devices. On behalf of PACE IT, thank you for watching this session, and I hope you watch another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on Introduction to Network Devices Part 3. Today I'm going to be talking about spam filters, and then we're going to conclude with a brief discussion on some network devices. And with that, let's go ahead and begin this session. Of course, I'm going to begin by talking about the spam filter. So what is spam? In most cases, spam is defined as unsolicited bulk email, or UBE, or sometimes it's called junk mail. The spammer, that's the person who is sending the spam, is hoping that the recipient will buy a product or service. While in most cases the receiving of spam isn't a security threat in itself, it is considered a waste of resources, which in a way is a security threat. There are various filters that are available for spam. These can be put in place, usually on an SMTP server, to reduce the amount of spam that is received by the end users. These filters include the Real-Time Blacklist, or RBL. This is a subscription service that provides a list of known IP addresses of spam hosts, which then allows them to be blocked from reaching the SMTP server. Then there is the connection filter, which is prohibiting a list of specific IP addresses from connecting to an SMTP server. There are also recipient filters. This is blocking messages sent to a particular recipient or end user. There are also sender filters. This is blocking messages sent from a particular entity. And finally, there is the sender ID filter. This allows an SMTP server to review the sender policy framework, or SPF record, of the sender in DNS. If the sending SMTP server is listed, the message is accepted. It's not counted as spam. The first known instance of spam occurred in 1978 and involved an advertisement for Digital Equipment Corporation, that's DEC, computers. While the reaction from this spam was largely negative, it did result in some sales, and guess what? The spam industry was born. When the term spam became associated with unsolicited bulk email is unknown, but we can blame Monty Python's Flying Circus for the term spam. In 1970, they aired a skit in which the word spam keeps getting used. As a matter of fact, it's used in a song, and it effectively blocked useful communication. That's how a lot of people feel about spam. Not that it's necessarily harmful, but that it can hinder useful communication. Now let's move on to a brief discussion of some network devices. First up is the Web Security Gateway. It's a system designed to protect networks from malicious content that is on the internet. It can be used to filter out prohibited content. It can also be used to scan for malicious code. In some cases, these systems can also be used as a data loss prevention measure. In these cases, all outgoing content is scanned. If sensitive content is discovered in the scan, it's not allowed to leave the network. This helps entities to keep their secrets within their own networks. Not really a device on its own, but we need to discuss it anyways, is the protocol analyzer. It's often called a packet sniffer. It examines the network behavior at a very basic level. They allow the examination of the individual packets of data that are flowing on the network. They can be used to see what is consuming network resources, as in, is a broadcast storm occurring or is an interface going bad? Protocol analyzers can help to identify that. They can also be used to identify a network breach or attack. Protocol analyzers can also be used to study the methods that were used to create a network breach. Wireshark is a common protocol analyzer that is often used, and better yet, it's free. The Web Application Firewall is an application layer, or Layer 7, firewall that is used to control HTTP traffic that is allowed to reach the web server. This allows for greater inspection and control of messages and traffic that is destined to a network's web servers. They are configured to protect the servers from common attacks. They differ from normal network firewalls in that they are only concerned about what is attempting to reach the web server. Network firewalls, on the other hand, attempt to protect the network as a whole, which means that the Web Application Firewall is much more specialized and allows for more granular control. Now that concludes this session on the Introduction to Network Devices Part 3. I began by talking about the spam filter, and I concluded with a brief discussion on some network devices. On behalf of PACE IT, thank you for watching this session, and I hope to do another one soon. Good day, I'm Brian Farrell, and welcome to PACE IT's session on integrating data and systems with third parties. Today I'm going to talk about evaluating the risks of integration, and then I'm going to conclude with some considerations of integration of data. I have a fair amount of ground to cover, so let's go ahead and begin this session. Of course, I'm going to begin by talking about the need to evaluate the risks of integration. There are multiple reasons why systems and data may be integrated with third parties. The real key is to know the risks associated with that integration. Systems and data may be required to be integrated because of a joint venture with another entity, or when implementing a cloud computing solution, there will be a need to integrate systems and data. In some cases, the need for integration is well known and intentional, while in other cases, it may not even be recognized as happening. When people are using social media, they may actually be integrating company data with a third party. In all cases, there are risks associated with the integration of systems and data with third parties. Now let's discuss some of the considerations of integration. First up is risk awareness. Always evaluate the risks when thinking about integrating systems and data with a third party. So what are some of those risks? Well, the data may reside outside of the control of the business. The network transmissions may be vulnerable. The other side of the integration may not be as secure as your side. And finally, that third party may go out of business. What happens then? Those are some of the risks that you need to be aware of. The onboarding and offboarding of business partners is another consideration. Procedures and systems need to be put in place that will allow authorized people from the third-party business partner to access the appropriate systems and data within your network. This is the onboarding process. Implementing an identity and access management system, or IAM system, can help ease the burden. Procedures and systems also need to be put in place to remove access once the partnership is terminated or the authorized person leaves the business partner. This is the offboarding process. Then you need to consider the interoperability agreements. If the risks of integration are deemed acceptable, some additional agreements should be created to help the process along. There should be a memorandum of understanding. This is a document that is created that establishes an agreement between two parties. Another document that might be needed is a blanket purchase agreement. It's a document that is created and used to cover repetitive needs for products or services. There should be a service level agreement, or SLA. It's an agreement that specifies the guaranteed uptime of a system. And finally, there may be the need for an internet service agreement. This specifies any data limits placed on an internet connection and should also contain a guarantee of the amount of uptime of that internet connection. Another consideration of integration is data backups. Cloud storage of data backups may be the best solution to offsite storage for the backups, mitigating the risk of data loss in the case of a disaster, because it won't be on your site. But there is a risk associated with this because that backup of your data is no longer in your possession. To mitigate this risk, all backups that are stored with a third party should be encrypted. Then there's data ownership. There needs to be a clear understanding of data ownership before the integration of systems and data is undertaken. Some third parties consider all data stored on their systems as being their data, no matter where that data originated from. Then there's compliance and performance standards. Read all agreements with third parties carefully to ensure that what they offer and/or provide meets with the compliance and standards that are required. In some cases, it is not only inappropriate to integrate data with a third party, it may actually be in violation of the law. Always follow security policies and procedures. In all cases of systems and data integration, security policies and procedures should be in place to protect the integrity of the business's systems. At least one of the policies needs to define what is considered to be unauthorized sharing of data. And this moves us to a consideration of social media. Social media represents a type of data integration that may be difficult to control. With the increased use of social media networks and applications, company data may not necessarily be under the control of the proper entities. Companies should strive to train personnel on what is appropriate to share on social media and what should not be placed out in the open. It is possible for sensitive company information to be placed on the internet through the use of social media. That concludes this session on integrating data and systems with third parties. I began by talking about the need to evaluate the risks of integration, and then I concluded with some considerations of integration. On behalf of PACE IT, thank you for watching this session, and I hope to do another one soon. Good day, I'm Brian Farrell, and welcome to PACE IT's session on Types of Application Attacks, Part 1. Today we're going to begin with Application Attacks Defined, and then we're going to conclude by talking about some common application attacks. There's a fair amount of information to go over, so let's go ahead and dive into this session. We're going to begin with a definition of application attacks. Due to improvements in modern network security methods, hackers may not be able to easily exploit network resources or devices. As these security improvements have developed, in many cases, the attackers have shifted their focus to application attacks. The hacker will focus on exploiting weaknesses in the software and operating systems that people use every day. In many cases, the security used to protect software from exploitation is not as robust as the security that is used to protect networks. A poorly developed application can often give the hacker administrative control of a system if the exploit is executed properly. And that briefly defines an application attack. Let's move on to the discussion about common application attacks. First up is the cross-site scripting attack, or the XSS attack. The attacker inserts script code into a form on a web page that then gets submitted to the server. You would think that that would be an attack against the server, but it's not. The server then submits the script code to another client system, which then executes the script. It's the client system that receives the script back from the server that is the victim. Cross-site scripting is often used to attack the database servers that are used to support web pages. Then there is the SQL injection attack. SQL is the common language used to manipulate databases. Most businesses and web applications use SQL to retrieve data from databases. To perform the attack, the hacker inserts SQL commands into the application, usually from an input field, knowing that the application will pass the command to the database application. The injected SQL commands will then modify the database, as in inserting a new username and password for the hacker to use in further exploitation. With a buffer overflow attack, the hacker sends more information to the application than the application's memory buffer can handle, therefore overflowing the buffer. The additional information will often be placed in memory outside of the controls that are included with the buffer. If the hacker can get the right information stored outside of the buffer, he or she can execute code with administrative privilege, and that spells trouble. An integer overflow attack is similar to a buffer overflow attack, but involves exploiting the mathematical functions of an application. When a mathematical function returns an integer, that's a number, larger than the memory space that has been allocated to receive it, applications often respond in unexpected ways. And guess what? This represents a security issue. The directory traversal command injection attack is a popular attack against web servers in which the hacker attempts to traverse the web server's directories to the point where he or she can execute commands on the underlying operating system. The attacker manipulates URL requests in order to move through the directories and get to a command prompt on the underlying OS. Once there, they have control. The LDAP injection attack uses the same principle as the SQL injection attack, but exploits LDAP calls instead of SQL commands. Then there is the XML injection attack, which uses the exact same principles as the SQL injection attack and the LDAP injection attack, but it exploits extensible markup language to modify the targeted application. One of the largest threats that network security personnel face is the unknown vulnerability. It's hard to defend against what you don't know. Network and systems administrators expend a fair amount of effort protecting the assets under their control. They can do a good job of hardening their systems, but not a perfect job. The main problem lies with zero-day attacks. Zero-day attacks take advantage of either new or very recently discovered vulnerabilities in applications, which means that the network and systems probably haven't been hardened against them yet. The unfortunate reality is that attacks keep changing and security experts must be willing to adapt in order to keep pace. The best defense against application attacks begins with the application's developer. Most attacks against applications involve exploiting outside input to the application. By using proper data validation techniques, application developers can stop most application attacks from succeeding. All data validation techniques should be thoroughly tested by the developer to ensure that they are effective. It is even advisable to have an unaffiliated person or organization attempt to bypass the validation techniques in order to increase the effectiveness of the testing. And that concludes this session on types of application attacks, Part 1. We began with application attacks defined, and then we concluded with a discussion on some common application attacks. On behalf of PACE IT, thank you for watching this session, and I hope you watch another one soon. Good day, I'm Brian Farrell, and welcome to PACE IT's session on Secure Network Administration Concepts. Today I'm going to be talking about rule-based management, and then we're going to conclude with some additional secure network administration concepts. I have a fair amount of ground to cover, not a whole lot of time, so let's go ahead and begin this session. First up is rule-based management. So let's begin this by defining rule-based management. It's the implementation of rules at the technology level which are used to create a secure network environment. Rule-based management should be designed and tested to ensure that the rules function as expected. There's nothing worse than implementing a rule and then not having it behave as it was supposed to. Firewall rules fall under rule-based management. The firewall rules should be configured in such a way that only the required traffic is allowed to pass through the router. Whenever possible, the default rule should be to deny traffic. Once that default rule is in place, exceptions are then created that allow the required traffic to pass through the router. The last rule on any firewall should be an implicit deny statement. That means that unless explicitly allowed, the traffic is denied entry into the network. The access control list is another part of rule-based management. Now, the ACL should be implemented wherever possible. Firewall rules are also often called ACLs. Files and folders can have ACLs placed on them through the use of permissions. As a general rule, routers can have 2 ACLs per network interface. One ACL is on the inbound side of the interface, the other ACL is on the outbound side of the interface. And the 2 ACLs don't have to have the same rules. All ACLs should end with an implicit deny statement. As I said earlier, an implicit deny statement means that if it's not explicitly allowed in the ACL, the traffic or request is denied. Once created, the ACL should be tested thoroughly for functionality. That's to ensure that the required actions are allowed and to ensure that non-required actions are not allowed. Now let's move on to some additional secure network administration concepts. Now these concepts are pretty basic, but they're still important, and the first one is secure router configuration. That's locking the front door to your network. Put active ACLs in place. Disable default usernames and passwords. Require passwords for all access to the router, and whenever possible, use only secure protocols to access the router. Then there's port security on switches. This is locking a back door to the network. Enable security on all switch ports. This limits the ability of an attacker to gain access through an open switch port. MAC filtering is the security method that is most commonly used to secure switch ports. Then there's network separation. This is putting your eggs in more than one basket. Separate and group network resources by function and security needs. This can create more secure areas within a network. Network separation can be achieved through VLAN and VLAN management. Talking about VLAN management, this is keeping the fox out of the henhouse. First off, you should change the default management VLAN configuration. Whenever there's a default in place, you need to change it. Proper VLAN management keeps network traffic where it belongs. To allow inter-VLAN communication, the traffic has to pass through a router. So we go back to that secure router configuration. Then there are flood guards. This is blocking the most common of attacks. The most common network attack is still the denial of service or DOS attack. The attacker tries to flood the network with traffic to block legitimate traffic. But flood guards can recognize the pattern and halt the attack before the damage is done. Then there's loop protection. This is preventing unnecessary network traffic. Redundant routes can create routing loops. Routers use a time-to-live value and split horizon to combat routing loops. Redundant links on switches can also create loops within a switch network. Spanning Tree Protocol, that's STP, will negate these loops from ever occurring. If possible, you should implement 802.1x. This helps you to know exactly who has access to your networks. 802.1x is an authentication protocol used on wired and wireless networks. It requires users to authenticate, that is, prove who they are, against a central database before access to the network is granted. 802.1x is a good way to keep your network safe from nefarious users. You might want to consider Unified Threat Management. This is multiple security measures in one device. Unified Threat Management is a possible all-in-one security solution. UTM systems provide multiple security functions in a single network appliance. Just be aware that a UTM system may also create a single point of failure for your network. And finally, there's log analysis. This is knowing what is happening on your network all the time. Security, system, and application logs should be reviewed on a regular basis. All too often, they are only reviewed after a problem has occurred, when the signs of the problem were present in the log files before any damage had occurred. While reviewing log files may not be fun, they can help to prevent a problem from occurring in the first place. Now that concludes this session on secure network administration concepts. I began by talking about rule-based management, and then I concluded with some additional secure network administration concepts. On behalf of PACE IT, thank you for watching this session, and I hope to do another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on cloud concepts. Today we're going to be discussing cloud classifications, and then we're going to conclude by talking about types of cloud computing. I have a ton of information to impart, not a whole lot of time, so let's go ahead and begin this session. Of course, I'm going to begin with cloud classifications. Cloud computing is where the resources on the network are not actually physical in nature, they are provided to the user virtually. This can lead to a very fluid and dynamic environment, as required resources are normally only provisioned as needed and they are decommissioned once their use is completed. Most often, these virtual resources are not owned by the company that uses them, but are provided by a cloud service provider. While cloud computing is highly configurable and changeable, it does have some basic structures that are used in the classification of the type of cloud that is in use. There are 4 basic cloud classifications. There is the public cloud. This is where systems can interact with services and devices within the public cloud and on public networks, as in the internet, and possibly other public clouds. Amazon's AWS is an example of a public cloud. Then there are private clouds. This is where systems only communicate with services and devices within the specified private cloud. Private clouds are not open for the general public to purchase services. Then there are hybrid clouds. This combines aspects of both the public and private clouds. And finally, there is the community cloud classification. This is where cloud services are used by private individuals, organizations, or groups that have a common interest. And the community is responsible for what occurs within that cloud. Now let's discuss types of cloud computing. Because of the nature of cloud computing, it is very configurable to the needs and desires of the purchasers. Purchasers have many options beyond just the type of cloud service, as in public or private, that they want to provision. they may also determine what type of services they are going to require, from the most basic to the highly complex. So what types of cloud computing are there? Well, there's software as a service, or SaaS. The end user purchases the rights to use an application, think piece of software, without the need to configure the virtual servers that will deliver the application. Software as a service is usually delivered as a web application. It's opened and used from within a web browser. Then there is Platform as a Service, or PaaS. The user is provided with a development platform for the creation of software packages without the need to configure the virtual servers and infrastructure that delivers that development platform. And finally, there's Infrastructure as a Service, or IaaS. The end user is provided with access to virtual servers, which are configurable by the customer, and other virtual network resources. This creates a highly configurable environment in which customers can create the resources and performance that they require. In this situation, the end user supplies the software that is going to be used in the Infrastructure as a Service network, or they purchase additional SaaS applications. It is not uncommon for the type of cloud computing being used by an organization to be a mix of different types. Some departments may use IaaS, while a development team only utilizes a PaaS. Part of the advantage of cloud computing is only initializing resources as they are needed. In a private cloud situation, it is possible for the organization that is using it to actually own the cloud resources. If they do own the cloud resources, they may have it on their own site, or they may pay to have the resources hosted off-site. Cloud computing can be a great method of conserving company resources, but it also has several security considerations. When using hosting services, there is always the need to consider confidentiality. When the resources are out of the physical control of the company, it may be difficult to control access to those resources. In some situations, such as when a law requires a company to maintain physical control of the resources, cloud computing may be unacceptable. In addition to the physical control, there is also the problem of reliability and availability. The purchaser is having to rely upon the hosting service's ability to maintain system uptime and availability. Always perform due diligence research to ensure that the cloud provider is both reputable and reliable. As part of the research, it is also important to evaluate whether or not the resource is appropriate to be hosted. In some cases, you may find that it's not appropriate. Now that concludes this session on cloud concepts. I began by talking about cloud classifications, and then I concluded with a discussion on types of cloud computing. On behalf of PACE IT, thank you for watching this session, and I hope you watch another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on secure network design elements and components. Today I'm going to be talking about defense in depth, and then I'm going to move on to elements and components of network design. I have a fair amount of ground to cover, not a whole lot of time, so let's go ahead and dive into this session. We're going to begin by talking about defense in depth. Due to the complexity of modern networks, malicious attackers have multiple avenues that they can use to breach network security. This same complexity, though, also allows for security to be placed in multiple areas using different methods. By placing security at different levels and in different places, network administrators can increase the overall security posture of the network. This concept is known as defense in depth, or security in depth. Security should not just be placed on a single spot, as this creates a single point of failure, which should be avoided at all costs. Security should be in place at multiple layers of the network using a diversity of methods in order to create an effectively hardened network. Just as when peeling an onion, once a layer of security is stripped away, the attacker should find another layer waiting underneath. By using defense in depth, you should be able to create a highly hardened and secure network. With that out of the way, let's talk about elements and components of network design. First up is the demilitarized zone, or DMZ. The DMZ is a specific area, think zone, that is created, usually between two firewalls, that allows outside access to internal network resources, as in access to a web server, while the internal network remains protected from that same outside traffic. The external facing router allows specific outside traffic into the DMZ, while the internal router prevents that same outside traffic from entering the internal network, keeping it safe and secure. Another design element is network address translation, or NAT. NAT is a technique used to allow private IP addresses to be routed across or through an untrusted public network. The NAT device, which is usually a router, assigns a public routable IP address to a device that is requesting outside access. NAT has the added benefit of protecting the internal private network. Why is that? The private network's IP addressing scheme is hidden from untrusted networks by the NAT-enabled router, thus making it harder for a hacker to gain access to internal network resources. Now let's talk about NAC, Network Access Control. NAC is a method of controlling who and what gains access to a wired or wireless network. In most cases, NAC uses a combination of credentials-based security and some form of posture assessment for a device attempting to log onto the network. A posture assessment considers the state of the requesting device. The device must meet a set minimum standard before it is allowed access to the network. Common device assessments include the type of device, the operating system, the patch level of the operating system, the presence of anti-malware software, and how up-to-date that anti-malware software is. Then we have virtualization. Virtualization is the process of creating virtual resources instead of actual physical resources. Hardware, operating systems, and complete networks can be virtualized. A security advantage to virtualization is that if the virtual resource is compromised, it can be easily taken down, recovered, fixed, and then brought back online in very short order. Although I would recommend figuring out how it got compromised and filling that security hole. Subnetting is the logical division of a network. That's a single block of IP addresses being divided into discrete, separate networks. This can be done to match the physical structure of the network, as in if your network only requires enough addresses for 100 nodes and it doesn't need all 254 nodes of a Class C address. Subnetting can also be done to increase the security of the network by segmenting resources by need and security level. Since I just brought up segmenting of resources, let's talk about that a little bit more. Security can be increased by segmenting a network based on resources and security needs through the implementation of virtual local area networks, or VLANs. The segmentation can be done based on user groups, as in a VLAN for the sales department and another VLAN for human resources. The segmentation can be done based on resource type, as in a VLAN for file servers and another VLAN for web servers. Commonly, segmentation of resources is accomplished with a combination of both user groups and resource type. The use of VLANs supports a more secure, layered approach in the network design. In modern networks, it is not uncommon to need to allow remote access to local network resources. Remote workers often need to access resources that are located on the main business network. This requires the use of remote access technology in order for it to happen in a secure manner. Remote access can occur using telephony technology, as in using a dial-up VPN, or through the use of a different type of virtual private network. In all cases, secure protocols and methods should be used in order to ensure the security of the local network. For example, one of the forms of Extensible Authentication Protocol, EAP, should be used when allowing remote access. Now that concludes this session on secure network design elements and components. Today we talked about defense in depth, and then we concluded by discussing some elements and components of network design. On behalf of PACE IT, thank you for watching this session, and I hope to do another one soon. Good day, I'm Brian Farrell, and welcome to PACE IT's session on Common Network Protocols, Part 1. Today we're going to be talking about IPv4 and IPv6, and then we're going to conclude with network storage protocols. There's a fair amount of ground to cover, so let's go ahead and begin this session. Of course, I'm going to begin by talking about IPv4 and IPv6. With Internet protocols, IPv4 still has dominance over IPv6 in the network. This will change, and it is already beginning to do so. Both IPv4 and IPv6 operate at layer 3, the network layer, of the OSI model. Both IPv4 and IPv6 operate at the Internet layer of the TCP/IP reference model. The protocols are similar in function and yet are different in how they provide those functions. Both protocols are responsible for network addressing and routing operations within a network or networks. While IPv4 has performed these duties adequately for many years, IPv6 is slowly assuming those responsibilities and will eventually be the dominant protocol. As a matter of fact, most of the world is now out of routable IPv4 addresses, which means that the switch to IPv6 is already starting to occur. So let's do an overview of both IPv4 and IPv6. And we're going to start with IPv4. It's a 32-bit addressing scheme that provides over 4 billion possible unique network addresses. It's commonly represented in a dotted decimal format. The numbers are separated by decimals. Each unit represents 8 bits or 1 byte. IPv4 can use different methods of transmitting data through the networks. It can use unicast, which is one-to-one communication. It can use multicast, which is one-to-a-few communication, or it can use broadcast transmissions, which is one-to-many communication. IPv6, on the other hand, is a 128-bit addressing scheme that provides over 340 undecacillion possible unique addresses. That is a lot of addresses. It's commonly represented in a comma-separated hexadecimal format. Each set contains 2 bytes, which is equal to 16 bits, and each set is separated from the others by a colon. Like IPv4, IPv6 uses unicast and multicast transmissions, but it does not use a broadcast type transmission. It does use anycast transmission, which is one to the closest communications, as one of its means of replacing the broadcast transmission. With that done, let's move on to network storage protocols. Before we move on to the protocols, let's talk about the storage area network and the network attached storage. The storage area network, or SAN, and the network attached storage, the NAS, often get confused with one another, but they are actually very different. The SAN is an actual network of devices that have the sole purpose of storing data efficiently. The NAS is a specifically designed network appliance that has been configured to store data more efficiently than standard storage methods. They still kind of sound similar, but the difference is that the NAS is a data storage appliance that is placed on a network, while the SAN is a network of data storage devices. It's not uncommon for the storage area network to contain multiple network-attached storage devices. Now let's move on to the protocols. We're going to start with fiber channel. It's a high-speed network technology that was originally developed to operate over fiber optic cables only. The standards have been modified to allow the use of copper cabling in conjunction with the fiber optic cables. It's commonly used to connect storage area networks together. Fiber channel uses Fiber Channel Protocol, or FCP, as its transport layer protocol, or its layer 4 protocol, to transmit SCSI, that's Small Computer System Interface, commands to storage devices, as in it uses FCP to transmit SCSI commands to network-attached storage appliances. Then we have FC over Ethernet, or FCOE. It's a layer 2 protocol used to transmit FC commands over an Ethernet network. As a layer 2 protocol, FCOE is non-routable. And finally, we have Internet SCSI, or iSCSI. It's an IP-based network standard used to connect data storage facilities and storage-attached networks. It is a layer 3 protocol. It allows SCSI commands and processes to take place over long distance, as iSCSI is a routable protocol. And that concludes this session on Common Network Protocols, Part 1. I talked about IPv4 and IPv6, and then I had a brief discussion on network storage protocols. On behalf of PACE IT, thank you for watching this session, and I hope you watch another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on Common Network Protocols, Part 2. Today we're going to be discussing the difference between ports and protocols, and then we're going to conclude with a discussion on some common protocols. With that, let's go ahead and begin this session. We're going to begin by discussing the difference between ports and protocols. And we're going to start with ports. Ports are a method of specifying what protocols and services to access. Many protocols and services use default ports so that they are easy to locate. There are 65,536 ports available to be used for communication. But port 0 is a reserved port. So in actuality, only ports 1 through 65,535 are available to be used. The first 1,024 ports are specifically assigned and are called well-known ports. These are assigned by the IANA, and if you would like to know more about those well-known ports, you can go to www.iana.org and look for assignments/port numbers. Ports can be thought of as a phone number extension. The IP address is the main number that you are trying to reach. The port number is the extension, think service or protocol, that you want to access. Now let's discuss protocols. Protocols can be thought of as the language that two applications on either side of the connection agree to speak. Protocols translate requests into services. Most protocols use predefined ports, but some protocols must be user configured, and some protocols don't have a designated port at all. With that done, let's move on to some common protocols. Let's start with HTTP, Hypertext Transfer Protocol. It's the primary protocol used to transfer data over the internet. It is assigned to port 80. And it can use either TCP or UDP as its transport protocol. Then there's HTTPS, which is Hypertext Transfer Protocol Secure. It's the primary protocol to securely transfer data over the internet using either SSL or TLS technology. In actuality, SSL should no longer be used. You should only be using TLS. but that's another discussion. HTTPS is assigned to port 443 and it uses TCP as its transport protocol. Then there's NetBIOS, which is Network Basic Input-Output System. It was originally developed to allow hosts to be able to communicate with servers. It's assigned to ports 137 through 139, and it can use TCP or UDP as its transport protocol. Let's move on to SMTP, Simple Mail Transfer Protocol. It's the protocol that is used to transfer email from a client to an email server, and it is also used to transfer email between email servers. By default, it's assigned to port 25 and it can use TCP or UDP as its transfer protocol. Then we have POP3, Post Office Protocol version 3. This is the protocol used by clients to retrieve email from servers. Once engaged, POP3 downloads all the messages from the server. The user cannot access email messages until they have been downloaded and are on their local device. It is assigned to port 110 by default, and it uses TCP as its transport protocol. Internet Message Access Protocol, or IMAP, is a protocol that's also used by clients to access email on email servers. It allows the client to administer and organize email on the email server before it's downloaded. Many businesses and organizations use IMAP to replace POP3 for their email client needs. IMAP is assigned to port 143 and it uses TCP as its layer 4 transport protocol. Let's move on to SNMP, Simple Network Management Protocol. It's a protocol that's used to monitor and manage local area networks. It's assigned to port 161 and uses UDP by default. Then there's DNS, Domain Name System. This is the protocol that's used to map computer names to their IP addresses. It's assigned to port 53 by default, and it can use TCP or UDP as its transport layer protocol. Then we have ICMP, Internet Control Message Protocol. It's a messaging service for Internet Protocol. The ICMP packets are carried as encapsulated IP datagrams. ICMP also provides information about networking issues. ICMP is not assigned to a default port, but it is still a common protocol. Telnet is a protocol used for remote access to systems. It is unsecure, but it is a handy bidirectional terminal service. It's assigned to port 23 and uses TCP and UDP as its layer 4 protocol. Secure Shell, or SSH, is a protocol that's used to encrypt data traffic on networks. It can be used in place of Telnet to provide a secure bidirectional terminal connection, and it's assigned to port 22. And SSH uses TCP and UDP. I mentioned TLS earlier, that's Transport Layer Security. It's a cryptographic protocol used to encrypt online communications. It uses certificates and asymmetrical cryptography to authenticate hosts and exchange security keys. TLS is a better option than Secure Socket Layer, which functions in a similar manner. That concludes this session on Common Network Protocols, Part 2. Today I talked about the difference between ports and protocols, and then we concluded with a brief discussion on some common protocols. On behalf of PACE IT, thank you for watching this session, and I hope to do another one soon. Good day, I'm Brian Farrell, and welcome to PACE IT's session on Common Network Protocols, Part 3. Today we're going to discuss some common protocols, and then we're going to conclude with a brief discussion about end-to-end security. There's a fair amount of ground to cover, so let's go ahead and dive into this session. Of course, I'm going to begin by discussing some common protocols. First up is FTP, that's File Transfer Protocol. It's a standard protocol for transferring files between computing systems. It does require user authentication, but it does not offer encryption, so it is not very secure. It is assigned to port 20 and to port 21, and it uses TCP as its layer 4 protocol. Surprisingly, SFTP, which stands for Secure File Transfer Protocol, is more secure than FTP. It is a protocol for transferring files between computing systems. It does require user authentication and encryption by default. It's assigned to port 22 using TCP and UDP when SSH is used for the encryption. By default, it's assigned to port 990 when using TLS or SSL for encryption, and it still uses TCP and UDP as its layer 4 transport protocol. Then we have SCP, Secure Copy Protocol. It's a protocol for transferring files between computing systems, again, and it requires user authentication and offers encryption by default. It is assigned to port 22 and uses TCP and UDP as its layer 4 protocol. Then there is TFTP, Trivial File Transfer Protocol. It transfers files between servers and clients. No user authentication is required and no encryption is in place. It's commonly used to upload and download network device configuration files. It's assigned to port 69 and uses TCP and UDP at layer 4 as its transport protocol. Then there is RDP, Remote Desktop Protocol. It's used in Microsoft networks by Remote Desktop Connection and Remote Assistance to make remote connections to desktop systems. It's assigned to port 3389 by default, and it also uses TCP and UDP at layer 4. Now let's briefly discuss end-to-end security. And we're going to do that by talking about IPsec, or Internet Protocol Security. It works at layer 3 and above of the OSI reference model. It's the most common suite of protocols used to secure a VPN connection. IPsec can be used with the Authentication Header, or AH protocol. AH only offers authentication services but not encryption. Or IPsec can be used with Encapsulating Security Payload, or ESP. ESP both authenticates and encrypts packets. It is the most popular method, but it does have more overhead than AH. Both Authentication Header Protocol and ESP will operate in one of two modes. The first mode is Transport Mode, which is commonly used between two devices, as in a host-to-host VPN. Or they can be used in Tunnel Mode, which is commonly used between two endpoints, as in a site-to-site VPN. IPsec implements Internet Security Association and Key Management by default, so it implements ISACAMP by default. ISACAMP provides a method for transferring security keys and authentication data between systems outside of the security key generating process. This is a much more secure process than other implementations. And there we have our brief discussion on end-to-end security. That concludes this session on Common Network Protocols Part 3. We started by discussing some common protocols and then ended with a brief discussion on end-to-end security. On behalf of PACE IT, thank you for watching this session, and I hope to do another one soon. Good day, I'm Brian Farrell, and welcome to PACE IT's session on wireless security considerations. Today we're going to be discussing some of the unique challenges of wireless networks, and then we're going to move on to security for wireless. There's a fair amount of ground to cover, not a whole lot of time, so let's go ahead and jump into this session. So let's talk about the unique challenge of wireless. Wireless networks can represent a special challenge in the network hardening process. One of the main tenets of network security is hiding your traffic. With wireless, it's impossible to hide your traffic because it flows over the airwaves. So with the proper equipment, anybody can see that traffic flowing on a wireless network. Also, end users will often install their own access points for convenience, allowing them to connect to the network wirelessly on their own. These rogue access points can create a vulnerability in the network as a whole. One method of combating these rogue access points is by conducting periodic site surveys. Using a combination of hardware and software, site surveys can help to locate rogue access points so they can be removed. Site surveys can also be used to ensure that wireless network signals are only present where they should be. The only wireless signals that should be present in any environment are those that are specifically authorized to be there. Now let's move on to security for wireless. First up is default username and passwords. All networking devices come with a default administrator username and password. A best practice is to change or disable the default administrator username and password when setting up the device. These defaults are well known and do represent a security vulnerability. Then there are the Service Set Identifier broadcasts, or the SSID broadcasts. A wireless access point will broadcast the names of available networks. By default, the SSID is broadcast in clear text, creating a vulnerability. A best practice is to set the WAP to hide the SSID beaconing. This will prevent the casual user from seeing the wireless network, but even with the beacon set to be hidden with the proper hardware and software, an attacker can still read those broadcasts. So that in itself will not stop a determined hacker. Then there's device placement. Wireless access points with omnidirectional antennas should be placed in the center of the desired coverage area. Omnidirectional antennas broadcast in all directions uniformly. So if you place it on the edge of where you want network coverage to occur, you're going to be placing your wireless signal where it shouldn't belong. Wireless access points with directional antennas can be placed toward the edge of the desired coverage area. Directional antennas broadcast in a specific direction only. Then there are power level controls. Most wireless access points come with the ability to adjust the power levels of the radio frequency signal. RF power levels should be set to reduce or increase the wireless coverage area to what is desired. All WAPs come with the ability to limit which layer 2 MAC addresses can connect to the wireless network. While this can increase the security of the wireless network, MAC addresses can be spoofed by an attacker. In addition to this, MAC filtering may not be appropriate in all situations, especially if there are a lot of wireless devices that come and go from the network, with new ones showing up all the time. In this case, MAC filtering is not the best option. A better option would be to enable encryption. So let's talk about encryption, and we're going to begin with WEP, which stands for Wired Equivalent Privacy. It's an older encryption standard that utilizes a pre-shared key to encrypt messages between the wireless access point and the connecting devices. WEP used the RC4 algorithm for the encryption. It is easily broken and should not be used. It can take an attacker just minutes to crack a WEP encrypted network. Better than WEP is WPA, that's Wireless Protected Access. It is also an older encryption standard, and it was used as an intermediate replacement for wired equivalent privacy encryption until a better standard could be brought online. WPA introduced TKIP, Temporal Key Integrity Protocol, as an additional security measure. TKIP creates a new security key for every packet that is sent across the wireless network. WPA can be broken and should not be used unless absolutely necessary. Better than WPA is WPA2 Personal. This is the current wireless encryption standard for the home or small business, and it utilizes a pre-shared key for encryption. WPA2 Personal introduced counter mode cipher block chaining message authentication code protocol with advanced encryption standard, so that would be CCMP with AES, as a means of addressing the weaknesses present in WEP and WPA. It cannot be easily cracked, but given enough time and computing resources, it can also be broken. But you can still consider it a secure encryption standard for the home or small office. Better yet, if you have the resources, you might want to implement WPA Enterprise. It is the current wireless encryption standard for larger businesses. Users are required to be authenticated before being allowed to connect to the wireless network. The authentication can occur using different methods that all fall within the 802.1x standard. The wireless access point will pass requests to log on to an authentication server, commonly a radius server, to authenticate the user before allowing access to the wireless network. Now let's talk about Extensible Authentication Protocol, or EAP. It's a common authentication protocol used by WPA2 to allow access to wireless networks. EAP packets are encapsulated within 802.1x packets, which are forwarded to an authentication server. There are different versions of EAP. There is LEAP, or Lightweight EAP, which is a Cisco proprietary method of implementing EAP. It was developed before 802.1x was standardized. Then there's PEEP, Protected EAP. It is a method of encapsulating EAP packets with transport layer security encryption in order to increase the security of the wireless transmission. There are some additional wireless network security measures that you can take. First up is the captive portal. Captive portals can be used to require users to authenticate through a web page when attempting to join a network. They're a common method used in publicly available wireless networks. You know, when you agree to the terms of service when you sign on to a public wireless network, that is a captive portal. Then there's VPN over wireless, which can be used to further increase wireless security. Wireless network access must be through a VPN. This adds an additional level of security in the network, as the VPN will implement IPsec as a means of end-to-end security. Now that concludes this session on wireless security considerations. We discussed the unique challenge of wireless, and then we concluded with security for wireless. On behalf of PACE IT, thank you for watching this session, and I hope to do another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on Risk-Related Concepts, Part 1. Today I'm going to be discussing control types, and then we're going to conclude with some policies for reducing risk. And with that, let's go ahead and begin this session. Of course, I'm going to begin by talking about control types. There are 3 different types of controls that can be put on network resources. The first one is management controls. These are any written policy, procedure, or guideline that is used to help secure network resources against attack or abuse. Management controls are often used to define and outline other control types. They are a very broad category of controls that can include security policies, hiring policies, security awareness training, etc., etc. Then there are technical controls. These are security measures that are used in controlling access to any particular resource that is available on the network. Technical controls can include physical controls used to limit physical access to networking equipment, as in locked server room doors. Some examples of technical controls beyond the locked server room doors include encryption, firewalls, passwords, etc. And then there are operational controls. These are the procedures that are put in place to help ensure that day-to-day operations can occur even after a risk event has happened. Some examples of operational controls include network redundancies, hot and cold site maintenance, and backup procedures. Now it's time to talk about policies for reducing risk. Any policy that is used to help secure the workplace and/or company data and networks is by default a security policy. Security policies document or outline what is allowed or not allowed to occur on the network from a security point of view. They are usually crafted at the upper layer of management with the help of knowledgeable IT personnel. In most cases, the network security policies are actually crafted by the IT personnel and then given to upper management to approve. Security policies give administrators the authority to put into place measures to protect the security of the network. In many cases, these security policies also give the administrators the authority to enforce the policies that lead to a hardened network. Now let's move on to some different policies. First up is the privacy policy. It's a policy that is used to educate employees and customers on information collection practices. Privacy policies will state why the information is collected, what information is collected, when it is collected, and how that information may be used. Many businesses now publish their privacy policies, and in some cases, privacy policies may be regulated. Then there is the Acceptable Use Policy, or AUP. It's a policy that documents what a company considers to be acceptable use of its IT assets. It may contain several sub-policies within the general AUP. The AUP should cover what is acceptable use of the internet, email, company laptops, and mobile devices. While outside threats may be difficult to deal with, the inside threat may be more dangerous to a network. It has been estimated that up to 80% of all data breaches can be traced back to a failure of security measures from within the network itself. Sometimes the breaches occur by mistake, but all too often these breaches are intentional. This implies that the greatest security threats are the people that already have been given access to the network. Policies and procedures can be put in place to reduce the risks that are associated with internal employees. Some of these policies include a least privilege policy. This is where administrators only grant the minimum amount of network privileges or access to network resources that are required to get the job done. This helps to minimize risk when an account gets compromised or in the case of a malicious network user. Then there's a separation of duties policy. Critical jobs are separated into different tasks with users only authorized to perform one of those tasks of the critical job. This helps to minimize the damage that can occur from fraudulent employee activities, as it would require more than one employee to take part in those fraudulent activities in order for it to be a success, and it's a whole lot harder for fraud to take place when there's more than one person involved. Then there are mandatory vacation policies. All employees should be required to take vacations, especially if they handle a critical task. This can lead to a reduction in the threat level from fraudulent employee actions. Employees know that someone else will be performing their duties in their absence and may discover any irregularities. And finally, there's job rotation. Mandatory job rotation requires that employees change job duties on a regular basis. This can lead to a reduction in the risk of fraudulent activities and has the added benefit of cross-training employees, especially for those critical tasks. Now that concludes this session on risk-related concepts, part 1. I began by talking about the different control types, and then I concluded with some policies for reducing risk. On behalf of PACE IT, thank you for watching this session, and I hope to do another one soon. Good day, I'm Brian Farrell, and welcome to PACE IT's session on risk-related concepts, part 2. Today I'm going to be talking about qualitative versus quantitative risk assessments, and then I'm going to talk about some other risk calculation factors. There's a fair amount of ground to cover, so let's go ahead and begin this session. Let's begin by talking about qualitative versus quantitative risk assessments. Many businesses dedicate a fair amount of their resources, both in time and in money, to perform risk assessments. In most cases, these risk assessments may be broken into one of two main categories. They may be either qualitative or quantitative assessments. Qualitative assessments are conducted based on the probability or likelihood of the risk occurring and the expected impact on the business. This type of assessment is not really concerned about the actual dollar impact, just about the likelihood that it's going to occur. Quantitative assessments, on the other hand, are conducted based on the projected cost in dollars if a risk event occurs. Now let's go into a little bit more detail. The basic formula for a qualitative assessment is the risk is equal to the probability times the loss, or the likelihood times the impact. Now, to create this assessment, several tables are built using the variables of the formulas. A risk table outlines the possible events, as in a data breach or hard drive failure. Then a probability or likelihood table outlines the possibility of the event occurring, as in not likely, likely, or most likely, with the value assigned to the likelihood. And then there's a loss or impact table. This outlines the impact to the business if the event occurs. Is the impact minor, medium, or major, with a value assigned to the loss? These tables are used collectively to create a qualitative risk assessment. When evaluating risks, quite often qualitative assessments are done first, and they're used to determine which assets and risks require a quantitative risk assessment. That's because quantitative risk assessments take more time, effort, and usually money. So let's talk about the quantitative assessment. It involves using the actual cost of a threat event to help determine how much to spend on preventative measures. You know, it doesn't make sense to spend more to prevent a risk from occurring than the risk is actually going to cost the business. Quantitative risk assessments can help when budgeting for a security solution to reduce the risk of occurrence. The first step is to determine the value of the asset. Now, this value may be the cost to replace the asset or the cost of downtime. It all depends upon what risk you're evaluating. The second step is to determine the exposure factor. This is the cost of a threat event expressed as a percentage of the value of the asset. Step 3 is to determine the single loss expectancy, or the SLE. The SLE is equal to the value of the asset as determined in step 1 times the exposure factor, or EF, as determined in step 2. Once you have the SLE, then you go on to step 4. Step 4 is to determine what the average rate of occurrence is. That's the number of times the threat event is estimated to occur each year. Once you have the average rate of occurrence, then you can determine step 5, which is to find the average loss expectancy, or the ALE. The ALE is the SLE times the ARO, or the single loss expectancy times the average rate of occurrence. What this gives you is the dollar amount that your security solution should fall below. So that's step 6. You need to determine which security solution that falls below the ALE will mitigate the risk of occurrence. With that done, let's move on to other risk calculation factors. Now, these are factors that may come into play when determining some of the figures that are used in the quantitative risk assessment. First up, we have the MTTF, the mean time to fail. This is the average time a device is expected to be operational in production before it fails. This is usually reported by the manufacturer, and it is a non-recoverable occurrence. That means when the MTTF hits, that asset is gone. Then there's the MTBF, the mean time between failures. This is the average time between failures of a system or device. Then we have the mean time to restore or recover. That's the MTTR. This is the average time required to restore or recover when a failure occurs. Then there's the RTO, which is the recovery time objective. This is the amount of allowable time a system or device can be down, and it can be measured in hours or minutes or even days. And finally, we have the RPO, the recovery point objective. This represents the portion of the system that is expected to be recovered after a failure. As in, the RPO may be that it's expected that you will be able to recover everything from the point of the last full backup or maybe from the last incremental backup. That concludes this session on risk-related concepts, part 2. I talked about qualitative versus quantitative risk assessments, and then I briefly discussed some other risk calculation factors. On behalf of PACE IT, thank you for watching this session, and I hope to do another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on Risk-Related Concepts, Part 3. Today I'm going to be talking about treatment of risk, cloud computing and virtualization risks, and then some other risk terms and concepts. I have a fair amount of ground to cover, not a whole lot of time, so let's go ahead and begin this session. Of course, I'm going to begin by talking about treatment of risk. Now, the treatment of risk is actually our approach to handling risk. Once a risk has been identified, there are 5 main approaches to dealing with it. There's mitigation. This is the implementation of some type of control, as in an administrative or technical control, to reduce either the probability of a risk occurring or the severity of the event if it does occur. Then there's acceptance. That's taking no action to either reduce the probability of the event occurring or the severity of the event if it does occur. This is deciding that the impact of the risk does not justify the expenditure of resources to get rid of the risk. Then there's transference. This is making the risk another entity's issue. It's usually done through the purchase of insurance. And then we have avoidance. This is where, after identifying a risk, it's determining to avoid pursuing any action that may lead to the risk event occurring. While risk can be avoided, this may mean the loss of a business opportunity. And finally, there's deterrence. An attempt is made to deter the risk from occurring, usually through the use of potential punishment, as in termination of employment or prosecution. Deterrence is one of the least common approaches to dealing with risk. Now let's move on to cloud computing and virtualization risks. Cloud computing can create benefits to a business. IT needs, including data storage, can be offloaded to another entity, thus reducing a business's cost. While this may be beneficial, careful thought must go into the decision-making process. This includes a thorough analysis of the risks that may be present. A review of the provider's security is in order before any business should place crucial data on a cloud provider's system. The reliability of the provider's system should also be evaluated to ensure that availability meets the business's requirements. Additionally, in some cases, data and applications cannot reside on a hosted system because this may violate regulations. Always do your due diligence before engaging in cloud computing and virtualization. This will allow you to mitigate the risks that may be involved. And now let's conclude with some other risk terms and concepts. First up is asset. It's any resource that a business needs in order to function. And it can be anything from as minor as a pen or pencil to as major as a metropolitan area network. Then we have the false positive. This is when an application or system implemented for security warns of a threat that is not actually present. It is common for anti-malware applications to block legitimate applications from executing due to a false positive. In these situations, it may be necessary to train that anti-malware application to allow that other software package to execute. Then there's the false negative. This is when an application or system implemented for security fails to warn of a risk that is actually present. While false positives may be an annoyance, false negatives are dangerous. The situation presents a risk in itself. The failure to warn or block an actual risk allows that risk to occur. Then there's vulnerability. In this situation, it's a weakness in the configuration of software or hardware. Then there's threat. It's an event that can cause harm or reduce the value of an asset. Then there's the threat target. It's a system or device that is the object of a threat event. Then there's the threat vector. It's the mechanism, tool, or path used to exploit a weakness in networks, systems, or software. And finally, we have the threat actor. This is the person or entity utilizing the threat vector to exploit a weakness. That concludes this session on Risk-Related Concepts, Part 3. I began by talking about treatment of risk, and then I moved on to cloud computing and virtualization risks, and then I concluded with a brief discussion on other risk terms and concepts. On behalf of PACE IT, thank you for watching this session, and I hope you watch another one soon. Good day, I'm Brian Farrell, and welcome to PACE IT's session on risk mitigation strategies. Today I'm going to cover the why of taking risks, and then I'm going to talk about some strategies for mitigating risks. There's a fair amount of ground to cover, so let's go ahead and begin this session. Of course, I'm going to begin with the why of taking risks. It seems to be a law of nature, inflexible and inexorable, that those who will not risk cannot win. And that's by John Paul Jones. And it neatly sums up the why of risk-taking. In the marketplace, there is no reward without taking on the risk of failure. This brings up an interesting quandary. Investors will often reward risk by increasing the value of a company. On the other hand, failure due to risk-taking often leads to changes in management. This leads to a situation where management can be both rewarded and punished for taking on risk. This makes management very uneasy. So management will often take on risk to gain the rewards while at the same time implementing strategies to mitigate the amount of risk that it is willing to assume. With the why covered, now let's talk about strategies for mitigating risk. First up is change management. All change represents a risk to systems. A small change in one system may have a ripple effect that multiplies through the whole system. Change management is implemented in order to evaluate changes for their effects on the system as a whole, which can bring to light some hidden risks associated with a change. Change management allows for changes to occur while at the same time mitigating the risks associated with those changes. Then there's review of user rights and user permissions. Users must be granted rights and permissions in order to function in their positions. These rights and permissions may, in fact, represent a security risk. Periodic reviews should be conducted on user rights and permissions to ensure that the principle of least privilege is being followed, thus mitigating risk. Periodic reviews should also be conducted on user rights and permissions to ensure that all unnecessary user accounts are removed from the system, also mitigating risk. Another strategy is to perform routine audits. Audits are reviews of systems that should be conducted on a regular basis in order to reduce risk. Security audits can be conducted on many different systems to evaluate different aspects of risk, including system configurations and vulnerability assessments. Then there's incident management. It's a type of after-the-fact mitigation technique. After a security incident has occurred, effective incident management can help to contain the damage. In addition to that, effective incident management can help to prevent that security incident from occurring again. Then there's the enforcement of policies and procedures. Effective policies and procedures can reduce the chances of a risk event from ever taking place. But this relies upon the proper enforcement of those policies and procedures to help prevent that risk event from occurring. Data loss prevention systems can be implemented as a type of technology control to mitigate the risk of loss or theft of data. DLP systems can be a software application or a network appliance. They are designed to analyze information traversing the network to help ensure that sensitive data remains contained inside the established safe boundaries. DLP systems can monitor network links and review what is being transmitted through protocols associated with instant messaging, email, FTP, HTTP. DLP systems may also be configured to scan storage systems to help ensure that data is being stored in the proper location. That concludes this session on risk mitigation strategies. I began by talking about the why of taking risks, and then I concluded with a brief discussion on some strategies for mitigating risks. On behalf of PACE IT, thank you for watching this session, and I hope you watch another one soon. Good day, I'm Brian Farrell, and welcome to PACE IT's session on basic forensic procedures. Today we're going to be discussing how to recognize the need for forensic procedures, and then we will conclude with some basic forensic concepts and procedures. There's a fair amount of ground to cover, so let's go ahead and begin this session. Of course, I'm going to begin by discussing how to recognize the need for forensic procedures. The first step in basic forensic is the recognition that forensic measures need to be taken, as in that a security incident has occurred. Most technicians, at least hopefully, will not need to deal with a murder mystery in the workplace. However, it is almost a certainty that they will have to deal with some type of security or legal issue, especially when supporting an organization's network. This will often require using a first response that includes forensic procedures. The response to security and legal issues needs to be done in a manner such that evidence is recorded and preserved. The first step is recognizing that something has occurred which needs to be documented and that evidence needs to be collected and preserved. With that, let's discuss some basic forensic concepts and procedures. Let's begin by discussing first responder responsibilities. The first item on any first responder's agenda is to secure the area and limit who has access to the area as much as possible. Do not power down computer systems at this time. Securing the area and limiting access is done to protect possible evidence from being contaminated. Document anyone who has access to the area after it has been secured. If necessary, at least to stop an ongoing computer attack, it is permissible to unplug the network cable. First responders need to document the scene thoroughly, including what is on any computer monitors. Video capture can be used to document the scene. Polaroid type pictures, not digital pictures, work well as evidence. It may also be necessary to diagram the area. The first responders should interview any witnesses as soon as possible. And finally, the first responders need to start the electronic evidence collection process by order of volatility. So let's discuss the order of evidence volatility. Electronic evidence is volatile and easily corruptible just because of what it is, so the order of collection is vital. And the collection process needs to be done from most volatile to least volatile. The most volatile of all electronic evidence is the contents of memory or the contents of RAM. There is software out there that will allow a first responder to dump the contents of RAM into a secure file to be collected as evidence. Next up are swap files. They're not as volatile as random access memory, but they're still very temporary in nature. Next up is network processes. All network processes that are active on the affected system or systems need to be recorded. And then the same needs to occur with system processes. Then there's file system information. This needs to be collected, including the attributes of all files. And finally, raw disk blocks. This is all of the contents on all of the disk drives of all of the affected systems. After isolating the affected system or systems from the network, a bit-level image of the system needs to be created. When creating the bit-level image, it is necessary to create the proper timestamps. Have the recording system match the time offset of the target system. It is necessary to create 2 copies of the bit-level image and to create a message digest of those images. This is to be able to prove later that the images have not been tampered with. One of the images should be securely stored and kept as evidence. The other image can be examined in detail. So there are 2 different types of system image. You can do a live system image or a static system image. With a live system image, this is capturing the system image before the system is powered down. This can be used to capture highly volatile evidence. There is a warning though, a live system image may change the target system's data structure, which will result in a change in the evidence. A static system image, on the other hand, is capturing a bit-level system image after the system is powered down. The hard drive or drives are removed from the system and connected to a forensic workstation with a write blocker placed between them. The write blocker prevents any changes from occurring on the target drive as its image is captured. All evidence requires a chain of custody. It's a document that identifies who collected the evidence, when it was collected, and who has had access to it since it was collected. A proper chain of custody document can prove that evidence has been accurately preserved, and the chain of custody can also be considered as part of the evidence. A chain of custody document will help to ensure that all evidence is admissible in court. A broken chain of custody will negate the collected evidence. A first responder should create a tracking log. This documents all the steps taken from the beginning of the initial incident response all the way through the end. This tracking log can also show all the steps taken during the forensic process. It can be used to help track internal resources expended on the incidents as well. And these resources can include both man-hours and other expenditures. This tracking log can also be used to justify expenses for management or clients. A type of forensic evidence that's often overlooked are network traffic files and log files. These create a history of events, which is a good source for determining what has occurred on a computer. Network traffic logs and browser history files can show where the system went on the internet and what actions were taken. Log files, as in system log files, application log, or security logs, can help to determine what has occurred with a system. And finally, there's big data analysis. There needs to be recognition that in some situations, big data analyst tools may be required. Big data in this situation refers to any set of data that is too large to analyze with typical data management tools. An example of this would be when analyzing data from a security incident at a financial institution. This can involve multiple exabytes of data. Now that concludes this session on basic forensic procedures. I began by discussing how to recognize the need for forensic procedures, and then I concluded with a brief discussion on basic forensic concepts and procedures. On behalf of PACE IT, thank you for watching this session, and I hope to do another one soon. Good day, I'm Brian Farrell, and welcome to PACE IT's session on Incident Response Concepts. Today we're going to talk about first responder responsibilities, and then we're going to conclude with some incident response procedures and concepts. I have a fair amount of ground to cover, not a whole lot of time, so let's go ahead and begin this session. Of course, I'm going to begin by discussing first responder responsibilities. The first responder to a security incident has two main responsibilities. First, to assess the situation, and second, to contain the damage. When responding to an incident, the first item to evaluate is the overall situation. To do this, the first responder needs to judge how widespread the incident is. It may involve a single system or it may involve multiple PCs. It could even possibly involve an entire department. The second main responsibility of the first responder is to isolate the incident and contain the damage. In most cases, this can be effectively achieved by removing the affected system from the network. This can be done by unplugging the network cable from that unit. If the damage is more widespread, it may be necessary to power down a network switch or other network device in order to contain the damage. But the first responder does need to make sure that that damage is contained and doesn't spread any farther. Let's discuss incident response procedures and concepts. First up is preparation. A security response team should be created by an organization before an incident ever occurs. The organization should be educated as to how everyone needs to respond to a security incident and how the response is to be conducted. Then there's incident identification. Every member of the response team should be capable of identifying a security incident. All members of the organization should be educated in how to identify a security incident. In many cases, it is the help desk personnel in an organization that will first recognize that an incident might be occurring. Then there are escalation and notification procedures. Once a security incident has been identified, the incident response team should be notified. All personnel should know how to contact the security response team. Then there are mitigation steps. After containing the incident, security response personnel will identify steps required to mitigate the situation. The steps may be as simple as requiring an antivirus software package to be updated, or the mitigation may be more complex, possibly installing a new firewall or a different security appliance. Once the security incident has been resolved successfully, a lessons learned report needs to be created. This documents what has occurred and how it was handled in order to help prevent the same situation from happening in the future. The lessons learned report should contain how the security incident happened, how did it get resolved, and how effective was that resolution. It should also contain a section on how can a similar occurrence be prevented in the future. The lessons learned report will be included in the final reporting documents. These reporting documents are used to educate and train the security response team for future incidences. They can also be used to educate and train end users on best practices to keep that security incident from occurring again. All incident response teams should have recovery and reconstitution procedures in place. These define how the system or systems are going to be returned to the state that they were in before the security incident occurred. First responders are responsible for isolating the incident. This means to quarantine or remove the affected device or devices to reduce the opportunity for more damage to occur, which leads to damage and loss control. Always identify the extent of the damage to help ensure that it is contained to only the affected systems. And finally, there's the concept of a data breach. A data breach is any time that sensitive data is made available to an untrusted source. Extremely sensitive data should never be allowed on the network. It should always be kept in offline storage. In all cases, sensitive data should always be encrypted. That concludes this session on incident response concepts. I began by talking about first responder responsibilities, and then I concluded with a brief discussion on incident response procedures and concepts. On behalf of PACE IT, thank you for watching this session, and I hope to create another one soon. Good day, I'm Brian Farrell, and welcome to PACE IT's session on security-related awareness and training. Today I'm going to discuss the security policy, and then we're going to conclude with some security awareness topics. There's a fair amount of ground to cover, so let's go ahead and begin today's session. Let's jump into our first topic, the security policy. A security policy is actually composed of many sub-documents that cover the expected behavior of personnel from a security perspective. It is created by personnel that is tasked with securing company assets, but it also has the backing of management. Without that management backing, it would be difficult to enforce a security policy, at least evenly. All personnel should be required to be trained on the security policy and then acknowledge such training with a signature. That signed document needs to be kept in their personnel files at all times. The individual sub-policies contained within the security policy will not only detail the expected behavior, but will also outline the disciplinary actions that can or will be taken if the policy is violated. Disciplinary actions can range from a simple verbal reprimand to termination or prosecution. When devising your training on security policies, there are a couple of things to keep in mind. The first thing to keep in mind is the role that the person that you're training occupies. This is called role-based training. When training on individual security policies, it is important to craft the training to fit the intended users. The different users have different training needs. Your general user just needs to know the what of the policy. What do they need to comply with? What does it take to comply? The technical user needs to know the how and the what. For the how, they need to know how that policy is going to be put in place and how they need to help enforce it. For management needs to know the why of the policy. They really don't care about the how or the what, but they need to know the why. Why are we putting this policy into place? All security policy training is vital. It helps to ensure compliance with regulations like the PCI DSS standard or with HIPAA standards. Security policy training also helps to ensure that security best practices are followed, thus protecting the organization from threats. This policy training also helps to ensure that internal standards are adhered to. Another thing to remember is that the threat environment is not static, and that means that neither should the security policy. The security policy should be changed to adjust for new threats and trends as needed. And once it's updated, the training cycle needs to start again. There are different types of training and different environments in which that training can be done. Different types of training can and should be employed to help ensure consistent awareness and compliance with the security policies. These different types and environments can also be used as refresher courses on the security policy. The most basic is the printed document. This can be used as part of the initial training after hiring, as it is easily tracked with a signed copy being on file. Then there's computer-based training, or CBT. This uses IT media to provide the training, and it also allows for an interactive experience with the added benefit of also being easy to track. Then there are seminars. These are usually half-day or full-day security policy seminars, which can be used to impart knowledge to large groups at one time. Then there are working lunches. They're similar to a seminar, but usually they will only cover a single topic. And finally, there's informal training. Security personnel should always be striving to help users and management understand the importance of the security policy. All training should be documented and tracked with the exception of informal training, and the reason for this is the documentation can be tracked and measured. Let's conclude with some security awareness topics. Most users take a fairly casual approach to IT security, even when they don't think that they do. Social networks are actually a security risk. It is all too easy for a user to share information on a social network that shouldn't be out in the wild. Sometimes this sharing is intentional, and they don't realize that they're sharing sensitive information. Then there are peer-to-peer type networks. These also represent a security risk. Just like social networks, a user may make information that should be kept in-house available on a peer-to-peer network. P2P networks are also vulnerable to security exploits and have been used as threat vectors in the past to introduce malware into other networks. All data and files should be classified as to their level of sensitivity. This is also called data labeling. In most cases, organizations are responsible for establishing the level of classification, as in top secret, secret, public, or private, but it's up to the organization normally. An exception to that would be if they had a contract with a governmental agency. After all data and files have received their classification, users should be assigned to levels of access. That is their clearance level. Personally identifiable information is our next topic. Personally identifiable information is any information that can be used to uniquely identify an individual, as in their social security number or possibly their driver's license number. PII should always receive the highest level of classification and restrictions. Personally identifiable information is highly sensitive, and as such, it should never leave the control of the organization. Then we have data handling and disposal. Policies should be put in place that specifically outline data handling and disposal methods. These policies should outline how data can be stored and the appropriate method of disposal, both for electronic data and physical data. If data is allowed to be placed on removable media, as in a USB flash drive, it should always be encrypted. That way, if the flash drive gets lost, the data is still secure. Hard drives can be sanitized by using overwrite software, or they may be physically destroyed. And if you're going to require physical destruction, I recommend contracting with a shredding company. And finally, we have user habits. It is up to security personnel to instill strong security habits into other personnel within the organizations. Items that should be focused on include creating strong passwords and good password management techniques, proper data handling techniques, clean desk techniques, physical security of the personnel, and finally, the company's policies on personally owned devices in the workplace. Now that concludes this session on security-related awareness and training. I talked about the security policy, and then we concluded with some security awareness topics. On behalf of PACE IT, thank you for watching this session, and I hope to do another one soon. Good day, I'm Brian Farrell, and welcome to PACE IT's session on physical security and environmental controls. Today I'm going to discuss control types, then we're going to move on to physical security, and we're going to conclude with environmental controls. I have a lot of information to give out, not a whole lot of time, so let's go ahead and jump into this session. Of course, we're going to begin by talking about control types. There are three main types of controls that can be used to mitigate security risks. There are administrative controls. These are often called management controls. They're written documentation that is used to help secure systems from risks. Often, administrative controls will be used to help outline the other control types. Then there's technical controls. These are security measures used to control access or reduce risk to any particular resource or asset. They may be digital in nature, as in a firewall, or they may be physical in nature, as in a door lock on a server room. And finally, we have operational controls. They're procedures that are put in place to help ensure that day-to-day operations can occur even after a risk event has happened, as in implementing the recovery procedure after a hard drive failure. The categories of control types can be further broken down into what they are designed to achieve. They can be deterrent in nature. They're used to deter an action from being performed, usually by the threat of discipline. Then there are preventative controls. They're used to prevent a security threat from occurring, as in locking server room doors to prevent unauthorized access. Then there are detective controls. They're used to detect the occurrence of a risk event, as in a network intrusion detection system detecting a firewall breach. And finally, there are compensating controls. They're used to compensate for any residual risk that may remain after another classification of control has been put into place, as in purchasing insurance to safeguard against loss resulting from a data loss event due to a network breach. Now let's move on to physical security. Physical security measures can be used for multiple purposes, including keeping people safe in the workplace. The use of proper lighting and signage can direct employees to emergency exits and/or keep them safe at night in the parking lot. Fences and barricades can be used to secure sensitive areas, while guards, used in conjunction with access lists, ensure that only authorized personnel are present, thus creating a safer work environment. Physical security measures can also be used to restrict access to sensitive resources through the use of alarms, as in motion sensors or closed-circuit sensors, or through video surveillance. With that covered, let's talk about some specific physical security controls. First up, there are hardware locks. This is keeping assets where they belong. It's a technical preventative control that can be used to keep resources secure. The locks may be simple or they may be more complex. Then there are biometrics. This is making people prove who they are. It's an authentication method that is based on a person's physical attributes, as in their fingerprints, retinal patterns, or voice patterns. Biometrics can also involve physical actions, as in using a person's typing style to authenticate who they are. Radio frequency ID badges, also known as RFID badges, or security tokens, can be used to determine the exact location of personnel within a facility. As an added benefit, they can also be used to activate or deactivate electronic door locks. Some work environments require more security than others. One example is the wiring distribution point of IT networks. Allowing unlimited access to the wiring distribution room is an extreme example of a security risk. Anybody would have access to all of the network's communication and/or equipment, thus making them the actual owner of the network, even if you think that you still are. In highly sensitive, risk-intolerant environments, it may be necessary to implement a man-trap to control access to specific areas of the organization. A man-trap often involves two locking doors with a space in between them. A person is allowed through the first door, which then locks behind them, but not the second door until after additional verification has occurred. This traps the person until authorization is granted. And now let's conclude with some environmental controls. A network's health and safety can be affected by more than just a network interface failing or a possible security breach. Network and systems administrators also need to be concerned about environmental factors, and some of those factors include electrical power, heat, and humidity. A properly designed HVAC system can aid in protecting critical components from damage or loss of functionality. This is especially true when they are designed with a hot and cold aisle approach. With this approach, the equipment's air intakes are pointed towards AC vents, while the equipment's exhaust fans are pointed toward the AC system's cold air intake. thus giving you a hot aisle for the exhaust and a cold aisle for the intake. One of the environmental controls that should be in place are power monitors. These are systems and tools that can be used to evaluate the amount of and the quality of the electrical power being delivered to your IT systems. Power monitoring is often deployed with or alongside an uninterruptible power supply or UPS. Humidity monitors should also be put in place. These monitors allow administrators to control the humidity levels within an IT facility. Some thought also needs to go into fire suppression systems. These need to be specifically designed for the resources that they protect. While a halon system may be able to extinguish a fire in a cubicle farm, they are probably not the appropriate type of fire suppression for that place. And finally, there's electromagnetic interference shielding, or EMI shielding. In some work environments, it may be necessary to use shielded cabling to protect networks from EMI. That concludes this session on physical security and environmental controls. I began by talking about the various control types, then I moved on to physical security controls, and I concluded with a brief discussion on some environmental controls. On behalf of PACE IT, thank you for watching this session, and I hope you watch another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on disaster recovery concepts. Today I'm going to be talking about disaster recovery sites, and then I'm going to conclude with a brief discussion on data backups. With that, let's go ahead and begin this session. Of course, I'm going to begin by discussing disaster recovery sites. In the business world, a disaster is any event that involves more than the day-to-day emergency response resources. It is a fact of life that disasters will and do happen. Any event that can prevent an organization from functioning normally, or at least somewhat normally, will have a major impact on the continued existence of that business. The more time that is spent non-operational, the harder it becomes to recover from a disaster. An organization should create a disaster response plan, also known as a DRP, in order to address these situations. The DRP needs to be a comprehensive plan that covers everything from the unfortunate loss of key personnel to the loss of a critical business site. There are several strategies that can be covered in the DRP that involve the loss of a critical business site. The first one is the cold site. A cold site is when a company creates a prearranged location that the organization can utilize in the case of a disaster. It is a backup space only. There is no IT infrastructure that is put in place or maintained at the cold site. In the case of a disaster, the business moves all personnel, systems, and equipment that's required to the site. It is the least expensive backup site to maintain, but it's also the hardest type of backup site to bring up to speed. Then there is the warm site. It is a prearranged location that an organization can utilize in the case of a disaster. It usually contains a pre-set up office space and some critical IT infrastructure components, as in copies of key servers and networking equipment. In the case of a disaster, the business moves all personnel, systems, and other necessary equipment to the site, and usually only requires the addition of the latest backups to get the system back up and running. But it is more expensive than a cold site and takes more time to bring up to speed than a hot site. So let's talk about the hot site. It's a prearranged location that an organization can utilize in the event of a disaster. It contains a duplicate of all equipment and systems necessary to perform all critical operations. In the case of a disaster, only personnel need to be moved to the site before operations can proceed. It allows for the quickest recovery of operations, but it's the most expensive of the backup sites to create and maintain. Backup sites can be further categorized. They could be a shared site or a time-shared site. It's an alternative disaster recovery site where the cost of maintaining the facility is split with another organization. In this situation, if the disaster is widespread, the organizations may be required to share the use of the facility. Then there are the exclusive sites. It's an alternative disaster recovery site where the cost of maintaining the facility is borne by a single organization. In the case of a disaster, that organization will not be required to share the facility, but it is more expensive than a shared site. Now let's conclude with a discussion on data backups. Data plays an extremely important role in the life of organizations. They may live or die based on the data that they need to utilize. This importance on data requires that data be kept and maintained safely. Without it, most organizations will not be able to operate until it can be recreated. This means that data backup plans and procedures are a vital part of any DRP. Backups should be stored off-site in order to safeguard against a disaster. Backups also play a key role in recovering from unexpected consequences or from the failure of a component. Backup schedules must be implemented and periodic tests should be conducted to ensure that the backup process is working. There's nothing worse than trying to install a backup and then finding out that it's not a good backup. There are different types of backup. There is the full backup. All data on the targeted system is backed up. It is the slowest backup method with the highest storage requirements, but it also leads to the fastest recovery period. When using a full backup for recovery, it only requires the last full backup file. Then there are incremental backups. Only new or modified files are backed up. This is the fastest backup method with the lowest storage requirements, but it leads to the slowest recovery period. When using incremental backups, the recovery process requires that the last full backup file is used and all of the incremental backups since that last full backup. And finally, there's the middle ground, which is a differential backup. Only data that has changed since the last full backup is saved. The time to backup is moderate, and it requires a moderate amount of storage, but it's also the middle ground on the length of time for recovery. With the differential type backup process, the recovery requires that the last full backup file be used and the last differential backup file. That's why it's the middle ground between the other two. The configuration files of network devices should also be backed up. Once a network device has been configured and is operating as expected, a backup of the configuration files and operating system should be created. This helps to speed up the recovery time in the cases of equipment failure or when a change in the configuration has an unexpected consequence. Now that concludes this discussion on disaster recovery concepts. I began by talking about disaster recovery sites, and then I concluded with a brief discussion on data backups. On behalf of PACE IT, thank you for watching this session, and I hope to do another one soon. Good day, I'm Brian Farrell, and welcome to PACE IT's session on Risk Management Best Practices. Today we're going to be talking about business continuity concepts, and then we're going to conclude with a discussion on fault tolerance. I have a fair amount of ground to cover, not a whole lot of time, so let's go ahead and begin this session. I am going to begin by talking about business continuity concepts. And before I begin talking about those continuity concepts, let's talk about best practices. A best practice is a technique or methodology that consistently returns superior results over another technique or methodology. Best practices can be standardized across an entire industry, a single company, or an individual. Best practices can also be customized to fit any given situation. The creation of a business continuity plan, or BCP, is a best practice that should be done within every organization. A BCP is a sub-element of a disaster recovery plan, or DRP. The BCP utilizes a business impact analysis to determine the impact of down or lost systems through the use of risk assessment techniques. The business impact analysis will help to determine which functions or systems are critical to the continuity of operations. Once identified, steps may be taken to reduce or mitigate risks to those assets. Critical system and component identification is vital to any BCP. If the loss of a system or component would result in significant lost revenue or in a safety situation, it is determined to be a critical system or component. These are often determined to be a single point of failure. A single point of failure is when the failure of a single device or component can bring the entire system down or have a disproportionate impact on operations. Single points of failure are most often mitigated by implementing redundancy. That's using multiple duplicate systems that immediately take over when a failure occurs. In some situations, single points of failure may be mitigated through high availability techniques. It's a similar concept to redundancy, but it involves data instead of systems. Part of any BCP is succession planning. It's the process of ensuring that if a key person, as in someone in a leadership position, to the organization is lost, that there are personnel who can step into the position right away, even if it is only on an interim basis. Then there's IT contingency planning. It's preparation of a recovery plan to be used when something fails or goes wrong within an IT system. It's very similar to a succession plan, but it's for IT. All business continuity plans should be tested on a regular basis. That means all of the elements of the BCP should be thoroughly tested before they are fully implemented and trusted. Tabletop exercises should be periodically conducted to ensure that the BCP is still valid. With tabletop exercises, the team responsible for the business continuity plan gathers and reviews every aspect of the BCP to determine if anything is missing and to review everyone's responsibilities during a disaster event. Now let's move on to fault tolerance. Building fault tolerance into IT systems is a main tactic used to remove single points of failure and to ensure high availability of data. Using a single server or other piece of hardware to run and maintain critical business functions represents a huge risk. If that server were to fail, it would have a severe impact on the operations of the organization. Fault tolerance is the process of putting systems and processes in place to reduce the impact of the failure of any single system. It can also be used to mitigate against the loss of a group of systems. Let's discuss server fault tolerance. This mainly involves the use of clustering, which is taking a single server's responsibilities and spreading them across multiple servers. In this situation, the duplicate servers are all called nodes. The active node is responsible for ensuring that the other nodes contain current copies of the data or processes. If a single node fails, operations continue uninterrupted. This also has the advantage of allowing for load balancing. As all the nodes contain current information, during peak periods the workload may be spread out among the various nodes. The cluster may be contained within a single facility, or it may be geographically dispersed. Geographic distribution has the added benefit of protecting against natural disasters, taking out the whole cluster. Hard drive fault tolerance is mainly achieved through the implementation of RAID. That's a redundant array of independent disks. RAID may be used to increase performance, or it may be used for fault tolerance, or it could be implemented to both improve performance and fault tolerance. But remember, not all implementations of RAID involve fault tolerance. So let's talk about the different types of RAID. There's RAID 0, which is also called disk striping. Data is striped across 2 or more disks, which leads to an increase in performance, but RAID 0 is not fault tolerant. Then there's RAID 1, which is also called disk mirroring. Data is duplicated across 2 or more disks, which does lead to fault tolerance, but it does not lead to an increase in performance. To achieve both an increase in performance and fault tolerance, you may want to implement RAID 5. This is also called disk striping with parity. Data is striped across multiple disks, 3 or more, along with a parity bit. Now this is fault tolerance, and it has performance that's close to that of RAID 0, but not quite. If you have the resources for it, you should consider RAID 10, which can also be called RAID 1+0. Now this is a stripe of mirrors. It requires 4 or more disks, as it includes a mirror set and a stripe set. Now RAID 10 has the best performance and is highly fault tolerant. That concludes this session on risk management best practices. We began by talking about business continuity concepts, and we concluded with a brief discussion on fault tolerance. On behalf of PACE IT, thank you for watching this session, and I hope you watch another one soon. Good day, I'm Brian Farrell, and welcome to PACE IT's session on the goals of security controls. Today I'm going to be talking about confidentiality, integrity, and availability controls, and then I'm going to conclude with a brief discussion on security controls. I have a fair amount of ground to cover, not a whole lot of time, so let's go ahead and begin this session. Of course, I'm going to begin by talking about confidentiality, integrity, and availability controls. No matter how a security control is implemented, it always has a goal. And that goal is to keep systems and data or personnel and facilities safe. In some cases, these end goals can be combined. However, in most cases, they are deployed separately to achieve the goal. It is not uncommon for the categories to work together to increase the overall security of data and systems. When the focus is on systems and data, the security control can be placed into one of 3 categories. And those categories are confidentiality, integrity, and availability. This is commonly known as CIA. So let's talk about confidentiality controls. This is using technological controls to ensure that only authorized personnel can gain access to the information. This is done through several different methods. It can use access control or permissions. This is explicitly establishing who can access the information. The person requesting access must have explicit permission to be able to access it. Then there's encryption, which ensures confidentiality by using an algorithm to make the data unreadable unless the appropriate security key is present. Encryption can be placed at multiple levels. It can be placed at the file level, the storage level, or on the communication channel. Then there's steganography. This is concealing data, as in a text file, within a graphics file. The person receiving the graphic file must use steganography software to read the secured data. In many cases, access control and encryption are used together to increase the confidentiality of data or systems. Now let's move on to integrity. This is using technological controls to ensure that when data is sent from a source, exactly the same data is received at the destination. In short, integrity is authenticating the data. This can be achieved through hashing. Hashing is using a mathematical algorithm to verify that no change has occurred to the data in transit. Once received, the hashed value of the data is used to ensure that the integrity of that data has been maintained. Certificates can be used as an integrity control. Now, certificates are a cryptographic means of transporting or exchanging security keys. This ensures the integrity of the security keys. Then there's digital signatures. This is using a combination of certificates and security keys to authenticate the sender of a message or data. In short, ensuring the integrity of the source. Quite often, integrity controls are used in conjunction with confidentiality controls. Then there is availability. This is using various control types to ensure that data and systems are always available when required. Availability controls can be implemented through various methods. One method is fault tolerance. This is ensuring that even in the case of a failure, data is available. It can be achieved through multiple methods, including RAID or server clustering. Then there's redundancy. This is ensuring that systems are always available by using multiple units, as in using a partial mesh topology to guard against the failure of a network switch. Backups are another way of ensuring availability. This ensures that data can be recovered in the case of loss or corruption. Patching is another method of helping to ensure availability. Patching ensures that systems and data are available by keeping operating systems and configuration files up to date, safeguarding against common systems attacks that might bring down those devices. Now let's have a brief discussion on safety controls. Security controls should also be put in place to ensure the safety of personnel and facilities. Often the responsibility for securing systems and data are separated from the responsibility to secure personnel and facilities, but not always. Without the people and facilities, the systems and data will not do much good. Some security goals should be put in place with this in mind. The security controls should cover disasters, as in a fire or earthquake, personal safety, as in all parking lots should have adequate lighting, and outside threats, as in controlling access to the facility. The controls also need to be tested on a periodic basis to ensure that all people know the controls and understand how they operate. Now that concludes this session on the goals of security controls. I began by discussing CIA controls, and then I concluded with a very brief discussion on safety controls. On behalf of PACE IT, thank you for watching this session, and I hope to do another one soon. Good day, I'm Brian Farrell, and welcome to PACE IT's session on types of malware. Today we're going to do a malware definition, and then we're going to discuss common types of malware. There's a fair amount of ground to cover, and we don't have a whole lot of time, so let's go ahead and jump into today's session. Of course, I'm going to begin with malware defined. Malware can be defined as any code-based attack that can be utilized against a system or network. In most cases, malware has been specifically designed to perform a malicious action. That is, it's been designed to cause harm. As such, it can also be defined as any software that harms or misuses the system, which, by the way, can include just slowing the system down. That also means that a poorly written software package can also fall into the definition of malware, even if harm was not the intent. Always thoroughly test any software package before deploying it in a production setting. This will help to reduce the chances of introducing unintentional malware into the network. With the definition of malware covered, let's discuss common types of malware. We begin with the virus. A virus is malware that has two jobs: to replicate and to activate. That is, to activate its payload. It requires a host program, a host machine, and user action to spread. Viruses cannot spread on their own. Viruses only affect drives, as in hard drives or USB drives. A virus often contains a destructive payload. Then there are Trojans. This is malware that hides its purpose by disguising itself as something that the end user desires, like a free game or a video of kittens on the internet. They're used to get the end user to download a virus package. Trojans are often the method that is used to establish botnets or zombie nodes. And then there is the worm. It is similar to a virus, but it replicates itself across a network without user interaction. It doesn't need a host file in order to operate. Worms will replicate themselves across the network, creating havoc. We have the rootkit. Now, this is a software package that gets installed on a system, giving the attacker privileged access to the system. It's usually installed in the root file. That's why it's called a rootkit. Most often, the attacker attempts to hide the rootkit from the administrator to avoid being removed from the system. It hopes that by being installed in the root, then there are logic bombs. It's a virus that, after getting installed on a system, waits for a specific event to occur before activating its payload. The application carrying the logic bomb will function normally until the trigger event occurs. Often logic bombs are triggered by date and time. Over the last couple of years, ransomware has become a popular type of malware. It's a virus package that takes over an infected system for the purpose of extorting money from the end user. Often the virus will encrypt all the files and folders on the infected system, effectively locking out the end user. The attacker extorts money from the owner because the owner can't access their files and folders until they get the encryption key to unlock the encrypted files. Then there are botnets. It's a collection of infected systems, often called zombie nodes, under the control of the attacker. The zombies are used to perform other types of attack. The zombie controller will often rent out the use of a botnet for other attackers to use. Adware is also considered a type of malware. It's a software package designed to automatically load advertisements on a system, usually in the form of pop-up windows. The goal is to entice users to purchase something. The result is usually just annoyance and poor system performance. And thankfully today, adware is easy to block. Then there is spyware. This is malicious code that collects information about the system and may change some settings on the system. Spyware may be programmed to send the collected information to an attacker at specific times, or the spyware may be programmed to save the collected information until the attacker performs another action, as in inserting a USB flash drive and issuing a command. A polymorphic virus is a virus package that self-mutates in order to avoid detection by antivirus applications. This allows the virus to avoid signature-based malware detection, which is why you might want to use a combination of signature-based and anomaly-based antivirus. Armored viruses are a virus package that attempts to harden itself against defensive action, making it difficult to be decompiled. Antivirus vendors often decompile or take apart viruses when they're developing countermeasures for those viruses. And finally, we have backdoor access. This is a type of malware that may be unintentional. When creating applications, developers often create backdoors into the program. Backdoors are a means of accessing an application or service while bypassing the normal authentication process. In most cases, the application is listening on a specific port for a request for access. If the developer forgets to shut the back door, then you may have an application that gets into production with a backdoor that is open. Also, there is malware out there that can be used to open a backdoor into a program, a computer system, or even a network. Now that concludes this session on types of malware. I began by discussing malware defined, and then I concluded with a brief discussion on common types of malware. On behalf of PACE IT, thank you for watching this session, and I hope you watch another one soon. Good day, I'm Brian Farrell, and welcome to PACE IT's session on a summary of types of attacks, Part 1. Today we're going to be discussing inside threats and attacks, and then we're going to conclude by discussing some outside threats and attacks. I have a ton of information, so let's go ahead and begin this session. We will begin with inside threats and attacks. The first inside threat is malicious employees. Malicious employees are difficult to defend against, as the threat is already inside the network. You must grant them resources in order for them to do their jobs. But one of the best defenses against malicious employees is using the principle of least privilege. This principle is only granting the least amount of authorization that is required for people to get their work done. And it is one of the best defenses against malicious employees. Then there's privilege escalation. This is attempting to raise a user account's privileges to an administrative level, thus giving them access to almost everything. Privilege escalation usually occurs due to a vulnerability that may be present in the operating system itself. However, the vulnerability may also be present in another piece of software. The best defense is to remove all known vulnerabilities from operating systems and software. As a matter of fact, that is a security best practice. Then there is social engineering. This is the process of using social pressure to cause somebody to compromise a system from inside the defenses of the network. The social pressure can be applied in multiple forms. It can come by phone, it can be in person, it can arrive via email, or even through a rogue website, or by any other method that applies social pressure on inside users to compromise the system. ARP cache poisoning is a threat and an attack. The ARP cache, which maps IP addresses to MAC addresses, is corrupted by an attacker, with the end result being that the attacker has control of which IP addresses are associated with MAC addresses. ARP cache poisoning is commonly used in man-in-the-middle attacks. A client-side attack is an attack on a system through vulnerabilities that may be present within software on a client system. The attacks often originate from internet applications or messaging applications, but they attempt to exploit a vulnerability on software that resides on a client machine inside of the defenses of the network. Then there are replay attacks. It's an attack that uses a packet sniffer to capture network session data. The attacker then resubmits the captured packets in an effort to gain access to the network. Transitive access attacks are also a threat. The attacker attempts to get a user to click on a hyperlink to a Microsoft Windows shared folder that's been exploited. If the user clicks on the hyperlink, the user's system is forced to send account credentials, allowing the attacker to attempt to get access to other resources via a set of valid credentials. Now let's discuss man-in-the-middle attacks. The attacker is not necessarily inside the network per se, but the attacker is between the two endpoints that are communicating on a network. The attack allows a malicious user to be able to view all network packets that are flowing between the communicating hosts. In a worst-case scenario, with a man-in-the-middle attack, may kick out one of the users and hijack the session. With that covered, let's move to outside threats and attacks. We begin with spoofing. An attacker attempts to gain access to network resources by having his or her system masquerade as a trusted system. This is achieved by modifying either the IP address or the MAC address of the attacking system so that it looks like a trusted system. Spam is unsolicited bulk email or junk mail that attempts to entice a person into buying a product or service. While in most cases the receiving of spam isn't a security threat, it is a waste of resources, which is considered a security issue. Related to spam is SPIM, or spam with instant messaging. This is when an attacker harvests instant message IDs and then attempts to entice the end user to click on a hyperlink that is included in an instant message. SPIM is often used as the first step in another type of attack, as in performing a farming type attack. DNS poisoning is where the attacker changes the DNS records for a specific website in order to redirect traffic to a malicious website. The change in DNS record can either be on the local DNS apparatus or it may occur at a higher level, as in at the Internet Service Provider's DNS apparatus. Typo squatting, or otherwise known as URL hijacking, is another common type of attack. The attacker sets up a malicious website using common misspellings of legitimate URL names. The attacker assumes that a certain amount of traffic will reach the malicious website merely due to user error. And you want to know what? They are correct. They will get a certain amount of traffic due to misspellings. Then there is the nefarious waterhole attack. The attacker compromises a legitimate trusted website. That means that they have planted malicious code on the website. As users visit the trusted website, the malicious code is executed and the attack is completed. Now let's conclude by talking about the denial of service threat, or the DOS threat. This covers a very broad category of threats to networks and systems. Any threat that can potentially keep users or customers from using network resources as designated can be considered a type of denial of service threat. And there are many DOS attacks and threats that are out there. We're just going to cover a few of them today. There's the permanent DOS attack. It's an attempt to permanently deny a network resource for others. It can be done by physically destroying a resource or by damaging, as in corrupting, the underlying operating system beyond repair. Then there's the traditional DOS attack. It's an attempt to flood a network with enough traffic to bring it down. By bringing down the network, they're keeping legitimate users from accessing it. The traditional DOS attack is commonly used with malformed ICMP requests. Then there's the distributed DOS attack, or the DDoS attack. It's a DOS attack in which more than a single system is involved in sending the attack. Often, a botnet is used to implement the DDoS attack. And finally, we have the Smurf attack, which is also known as smurfing. This is where a network is flooded with ICMP requests in which the source address for the requests appears to be that of the intended target. So that address has been spoofed. As the network responds to the ICMP requests, the victim is denied access to the network because they're getting flooded with bogus responses. Now that concludes this session on a summary of types of attacks. I began by talking about inside threats and attacks, and I concluded with a brief discussion on some outside threats and attacks. On behalf of PACE IT, thank you for watching this session, and I hope you watch another one soon. Good day, I'm Brian Farrell, and welcome to PACE IT's session on a summary of types of attacks, Part 2. Today we're going to be talking about sniffer and password attacks, and then we're going to conclude with a brief discussion on some common social engineering attacks. There is a whole lot of information to impart, so let's go ahead and begin this session. Of course, I'm going to begin by talking about sniffer and password attacks. Quite often, an attacker will use a sniffer type of attack in order to determine what other type of attack to use on a network. Sniffer attacks use specialized software to examine the network for vulnerabilities. That software may conduct a port scan, which is looking for open or vulnerable ports that can be exploited. Or the software may be used to examine network packets in order to determine what applications, protocols, and services are in use on the network, thus revealing some other vulnerabilities. In addition to that, the sniffer application may combine both a port scan and the packet capture capabilities, thus increasing the odds of the hacker finding a vulnerability. One common port scanning attack is the Xmas scan attack, or the Christmas tree scan attack. With the Xmas scan, each packet sent by the scanner has 3 of the possible 6 flags set. This lights up that packet like a Christmas tree, but it lights up the 3 specific flags to increase the chances of getting a return, but it also helps to keep that scan from being discovered. Unfortunately, end-user passwords often present an attacker with easy entry into the network. Even when network administrators try to create a strong password policy, end users often attempt to create easy-to-remember passwords. Usually, if the password is easy to remember, it is easy to crack. As an illustration, in studies conducted on passwords, some of the most common passwords that are used include 1, 2, 3, 4, 5, 6, 7, 8, the actual word password, QWERTY, as in a QWERTY keyboard, QWERTY, and let me in. These all are consistently some of the top passwords that are found, and they do not represent much of a challenge to the hacker. Attackers also have some other tools and attacks that they can use in a password attack. Let's talk about those tools and attacks that are used in a password attack. There is a dictionary attack. The attacker uses specialized software that contains a list of the most popular usernames and a list of all of the words in a specific language. The program runs through all of the possible combinations in an attempt to find one that works. Then there's the brute force attack. An attacker uses a password cracking application that mathematically calculates every possible password combination. Brute force attacks take a large amount of computing power and time in order to be successful, but given enough computing power and time, they will succeed. As a rainbow table may speed up the process of a brute force attack, it is often combined with the brute force attack. The rainbow table contains a list of all the possible characters and combinations that can be used to create a password. And then there's the hybrid attack. It uses a combination of the dictionary attack and the brute force attack. And finally, there is the birthday attack. It's an attempt to duplicate a hashed value that is used to authenticate a user or system. The attacker uses a program that hashes data in an effort to recreate a known hashed value. If enough data is input, eventually the hashed value will be duplicated and then the attacker can be authenticated. With that covered, let's move on to some common social engineering attacks. First up is the phishing attack. The hacker typically casts out a broad net of emails that appear to be from a trusted source, as in from a well-known bank or from a company like Google. These emails request that a user click on a hyperlink. The hyperlink connects to a malicious website that looks similar to the trusted website. And when the user inputs his or her credentials as requested, the attacker then steals the user's credentials and they end up with a set of valid credentials that they can use to perform fraud. Spear phishing is related to the phishing attack. The attacks are very similar, but spear phishing is more directed. The hacker's email appears to come from an even more trusted source, as in it might appear to come from the management of the organization that the user works for, or it might appear to come from a trusted coworker. Farming attacks are also a common type of social engineering attack. The attacker uses DNS poisoning to redirect traffic from a legitimate site to a different or malicious website. And finally, there's vishing. This is using the telephone to perform a phishing attack. The attacker impersonates a trusted source, or they attempt to impersonate a trusted source. Phishing attacks are awfully hard to pull off, but they are successful on occasion. Now that concludes this session on a summary of types of attacks, Part 2. We began by talking about sniffer and password attacks, and then we concluded with a brief discussion on some common social engineering attacks. On behalf of PACE IT, thank you for watching this session, and I hope to do another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on a summary of social engineering attacks. Today we're going to be discussing what makes social engineering effective, and then we're going to conclude by discussing some types of social engineering attacks. I have a lot of information to give you, not a whole lot of time, so let's go ahead and begin this session. We will start by talking about what makes social engineering effective. The largest vulnerability in any system tends to be the people who have authorized access to the system itself. Hackers often attempt to exploit this weakness in the system by applying social pressure to the people who have access to that system. It has been proven to be an effective means of breaching data security for many years, as it relies upon some well-known exploitation principles. In actuality, social engineering doesn't require very much technology in order to be effective, as you will find out later in this presentation. How effective is social engineering? Even the National Security Administration, the NSA, has proven to be vulnerable to social engineering attacks. It was the main method used by Edward Snowden to gain the illicit data that he took from the organization that he's been slowly divulging to the rest of the world. So what are the reasons for the effectiveness of social engineering? Well, the attacker may rely on authority. The hacker impersonates an authority figure. The victim believes that he or she must comply with that authority. The impersonation can occur through email, over the phone, or even in person if the hacker is really good. Then there's intimidation. The attacker uses a message that intimidates the victim. Therefore, due to fear, the victim succumbs to the pressure and compromises the system. The hacker may rely upon consensus or social proof. The hacker presents some known facts as proof that he or she is telling the truth. The victim ends up trusting the attacker based on the social proof or consensus. Then there is scarcity. The attacker persuades the victim that what is being offered is highly valued due to its scarcity. The target falls victim to human nature, which is usually greed. An example of this is the Nigerian prince scam that I'm sure all of us are familiar with. Then there's urgency. The hacker imparts a sense of situational urgency. The victim feels like he or she has to act now to fix a situation. The message delivered to the victim may arrive via the telephone or email, but it always implies that action is required now in order to avert disaster. The hacker may rely upon familiarity or liking. The attacker either uses a friendly tone or inserts herself or himself into the workplace. The victims tend to like the attacker or feel that they can trust the attacker. This is one of the main methods that Edward Snowden used to gain access to the information that he took from the NSA. He actually acquired it from coworkers who felt that they could trust him. Which moves us on to the last reason for effectiveness, and that's trust. The hacker exploits our human nature to trust, either by appearing to need the victim's help or by offering to help the victim. By appearing to be the victim of an unfortunate situation, the attacker fools the victim into succumbing to the attack, or the hacker may create a situation in which the victim appears to need the attacker's help, at which point the victim gets exploited. With that done, let's move on to types of social engineering attacks. First up is impersonation. Many social engineering attacks begin with the hacker using impersonation. the act of pretending to be somebody else. A common impersonation technique is where the attacker impersonates someone of perceived authority, causing the victim to feel as if he or she must comply. The attacker may impersonate someone who requires help. For example, the attacker pretends to be an end user who requires the assistance of a network administrator, getting them to reset the username and password to something that the hacker can use, and therefore giving the attacker unintended access to the network. There are many more examples of impersonation. Then there's phishing. The attacker typically casts out a broad net of emails that appear to be from a trusted source, as in from a well-known bank or from a company like Google or Microsoft. The email will request that the user click on a hyperlink. The hyperlink connects to a malicious website that then asks the user to input his or her credentials. Once the user does that, the attacker then steals the user's valid credentials so that they can use them for fraudulent purposes. The phishing attack may employ the principle of authority and urgency in order to get the victim to respond. Whaling is very similar to a phishing attack. However, instead of casting a wide net in order to get a few responses, the hacker targets a whale or a big fish. This is somebody with a lot to lose. The hacker specifically crafts the message to suit the victim's situation. The usual target of whaling is someone at the executive level of an organization. Vishing is a phishing attack that is conducted over the telephone, so it's voice phishing. Hoaxes are also a form of social engineering attack. It employs the principle of consensus or social proof in order to get the victim to perform an action. Most hoaxes are not targeted to a specific person or organization, but are crafted in order to cause widespread disruption. Often a hoax is further spread by users who don't realize that it is a hoax. Then there's shoulder surfing. It's a type of social engineering attack that relies upon the hacker being able to see the victim's screen or keyboard. The hacker tries to steal confidential information, often as in username and passwords, by watching the victim's actions and recording their keystrokes. Dumpster diving can also be used as a social engineering attack. The attacker goes through the trash of a person or organization in an effort to discover sensitive information. People often think that shredding is an effective means of preventing dumpster diving, but that all depends upon the type of shredder that is used. A cross-cut shredder is more effective than a strip-cut shredder. Strip-cut shredded material can actually be pieced back together. It's time-consuming, but it can be done. And finally, there's tailgating. This is a social engineering attack that is usually used to bypass physical security. The attacker waits or times the approach to a secure area in order to enter right behind an authorized person. The victim of a tailgate attack may actually hold the door open for the attacker, not realizing that they've just been socially engineered. That concludes this session on a summary of social engineering attacks. I began by talking about what makes social engineering effective, and then I concluded with a brief discussion on types of social engineering attacks. On behalf of PACE IT, thank you for watching this session, and I hope you watch another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on a summary of wireless attacks. Today I'm going to be talking about some common types of wireless attacks, and then we're going to conclude with a discussion on attacks on wireless encryption. I have a fair amount of ground to cover, so let's go ahead and begin this session. Of course, I'm going to begin with common types of wireless attacks. By their very nature, wireless networks tend to be more vulnerable than their wired network cousins. The best security for any network is for a hacker to not even realize that there is a network there to be hacked. Since wireless networks rely upon transmitting data over public radio frequencies, it is all but impossible to hide a wireless network from an attacker. The requirement to transmit data over the RF spectrum has led to the development of various types of attacks on wireless networks. So let's discuss some of those now. Word driving and word chalking is the practice of attempting to sniff out unprotected or minimally protected wireless networks. Once found, marks are placed on buildings, streets, and sidewalks indicating what networks are available and the possible vulnerabilities. Wireless networks are vulnerable due to the fact that they need to broadcast data over the air, so it's easy to capture those packets. Rogue access point attacks are when an unauthorized wireless access point, or WAP, gets installed on the network. The biggest culprit in the rogue access point attack are your own end users. They often install their own wireless access points for convenience and then don't properly secure them, opening a vulnerability in the network. But just because your own end users are the biggest culprits, don't think that it can't be implemented by a hacker. Let's discuss the jamming attack. All wireless networks use RF channels to transmit data on the network. It is possible to create enough interference on that radio frequency channel that it is no longer usable on the network. An attacker will often use jamming when performing a DOS, or denial of service, type of attack. However, jamming can also be used as a prelude to an evil twin type attack. Many of the modern wireless networking standards and devices employ techniques to mitigate the threat of jamming. I just mentioned the evil twin attack, so let's discuss that one. It's a type of rogue access point attack. A wireless access point gets installed and configured with a service set identifier, that's the SSID, which is also known as the network name, that is very similar. Good day, I'm Brian Farrell, and welcome to PACE IT's session on Types of Application Attacks Part 2. Today we're going to begin with a goal of application attacks, and we're going to conclude by divulging weaknesses in some applications. There's a fair amount of information to go over, so let's go ahead and begin this session. Of course, I'm going to begin with a goal of application attacks. Often the hacker's goal when attacking an application is to create the ability to execute arbitrary code remotely. This is only arbitrary in the sense that the application was not designed to execute the code. If the attacker can gain this ability, the code will often be executed at an administrative account level. Arbitrary code execution, or remote code execution, represents an extreme security risk, as it often has the ability to make changes to the underlying system, giving the hacker control of that system. When this occurs, it can be difficult to discover and stop. It's time to move on to divulging weaknesses in some applications. First up is the cookie. Cookies are text files that web developers use to store information about users. These are stored on the user's local machine. If the cookie is captured, it may reveal sensitive information about either the user or the website. This can lead to a future exploit. Similar to the cookie is the flash cookie, which is also known as an LSO, or locally shared object. It's a method that Adobe Flash programmers use to store information on a user's computer. It usually stores information about Flash applications that the user has used on the internet. LSOs can be used to track a user's internet activity and may represent a threat to privacy. Most LSOs remain on a user's system even if all other cookies are deleted. Specific action needs to be taken to remove LSOs from being stored. The attachment or file attachment may also represent a weakness. A file attachment is a document or application that is attached to an email message. Attachments are a commonly used threat vector, and they're used to deliver malicious code or applications to a user. Then there's the malicious add-on. An add-on is software that is installed into browsers to allow for additional features. If the add-on causes a deterioration in browser performance, it can be considered malicious. Some add-ons can exploit vulnerabilities present in the browser, creating a security threat. These can also be considered malicious. With header manipulation, hackers can modify the header data of an application in order to change how the application functions. Header manipulation can be used to modify how a web server processes information, or it can be used on file headers to conceal information. Session hijacking usually combines both a network and an application attack. With session hijacking, the hijacker waits until a communication channel has been opened between at least two parties, as in an administrator signs into a web server. The hacker then disconnects one of the parties and inserts herself or himself into the communication channel and takes over the session. The attacker typically uses a DOS or denial of service type attack to disconnect one of the parties. Once inserted into the communication flow, the hacker attempts to gain control of either sensitive information or the application itself. That concludes this session on Types of Application Attacks Part 2. We began with a goal of application attacks, and we concluded with divulging weaknesses in some applications. On behalf of PACE IT, thank you for watching this session, and I hope to do another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on Security Enhancement Techniques. Today we're going to be talking about network security enhancement techniques, and then we're going to have a brief discussion on detection controls versus prevention controls. There's a fair amount of information to go over. We don't have a whole lot of time, so let's go ahead and dive into this session. Of course, I'm going to begin by talking about network security enhancement techniques. If properly set up and reviewed, log files are an effective tool in helping to ensure the security of any networked system. Log files tend to generate a lot of information. Unfortunately, all too often, they are not reviewed until after a security incident has occurred. By carefully establishing the parameters that will be logged and properly training personnel on how to review the logs, security can be enhanced. Even if an incident does occur, there's a greater possibility of it being discovered earlier if log files are reviewed on a regular basis. The earlier an incident is discovered, the easier it will be for the response team to contain the damage. So let's talk about reviewing system logs. What are the logs that you should be paying attention to? The first one is the event log. It records system events that usually require user interaction. The event log is a good way to find out when users are accessing the system and which systems they are accessing. Audit logs should also be reviewed. They're a summary log of other log files that has been configured by an administrator to record and report on significant events. Security log files also need consistent review. These record security events that have occurred on the system. And finally, there are access logs. Most network devices can log who has accessed the system and when that access occurred. A good security enhancement technique is hardening individual systems. Security personnel should strive to harden all systems against attacks. This can be done by disabling all unnecessary services, disabling unnecessary user accounts, protect management interfaces and applications from unwanted access, and using password protection on all critical systems. Employing network security measures is another enhancement technique. Security personnel should strive to harden all networks against attacks. Some of the ways that this can be achieved is through the implementation of MAC filtering. This should be done on all switch and router interfaces. Limit what devices can connect to switches and routers. Disabling all unused switch and router interfaces is another recommended technique. Whenever possible, use strong authentication protocols. As in, whenever possible, use the 102.1x protocol. Another method to harden the network is to conduct periodic site surveys, both wireless and wired. This is to detect and remove rogue or non-authorized systems from your network. This should be done on a regular basis. Establish a strong security posture. An initial baseline of the security configuration must be created and reviewed on a regular basis. All systems brought online must meet or exceed the initial security baseline. Continuous security monitoring should be conducted to ensure that all systems continue to meet or exceed the baselines that have been established. As new vulnerabilities become known, they must be removed or remediated, and the security baseline needs to be updated at that point in time. It is now time for our discussion on detection controls versus prevention controls. Along with log files, there are other reporting methods that can be used to enhance the security of both a network and a facility. Alarms should be placed on all access points to critical areas of the facility, including unmanned fire exits, server rooms, and network equipment rooms. Alerts should be enabled on all networking equipment and applications that report access, both authorized and unauthorized, and those reports need to go to the appropriate administrators. When reviewing monitoring logs, security personnel should create graphs that show activity. These graphs can be used to establish current trends in use, access, security events, etc. These trend graphs make it easier to spot anomalous activities. The intrusion detection system versus the intrusion prevention system. That is the IDS versus the IPS. An IDS is a passive system that is designed to detect unauthorized system intrusions or attacks on a system. It is configured to only notify administrators when an event occurs. An IPS is an active system that is designed to detect unauthorized system intrusions or attacks on a system. It is configured to take specific action upon detection of an event, and the intrusion prevention system will notify administrators when an event occurs. Cameras are a passive system that can be used to detect when an intrusion or security incident has occurred at a facility. Guards are an active system that can be used to detect and respond to an intrusion or security incident at a facility. If the security requirements are great enough, cameras and guards make a good combination. That concludes this session on security enhancement techniques. I began by talking about network security enhancement techniques, and then I concluded with a brief discussion on detection controls versus prevention controls. On behalf of PACE IT, thank you for watching this session, and I hope to do another one soon. Good day, I'm Brian Farrell, and welcome to PACE IT's session on an overview of security assessment tools. Today we're going to be discussing types of security assessments, and then we're going to conclude with a brief discussion on assessment tools. There is a whole lot of information, not a whole lot of time, so let's go ahead and begin this session. We're going to begin by talking about types of security assessments. Security assessments are a necessity, but they will not do any good if the results are misinterpreted. It is vital that the person conducting the security assessments understands how to do them properly, as in they're using the proper tool for the job on hand, or the results may not be accurate. This could lead to an unknown weakness in the security of an organization. Just as important as using the proper tool is properly interpreting the results. A misinterpretation of the results can lead to an incorrect conclusion on the security posture of the organization. Because of this, it is crucial that security assessments be conducted with the correct tool so that the results may be properly interpreted. So the two go hand in hand. The proper tool needs to be used and the correct interpretations need to be done. There are several different types of security assessments. There is the risk assessment or risk analysis. This is the process of identifying all risks to all assets within an organization and determining how those threats will be treated. The usual steps to a risk assessment include identifying assets, identifying threats against assets, prioritizing the threats, and determining how the threats will be treated or handled. This moves us right into a threat assessment. This is the process of identifying the individual threats to individual assets within an organization. They are conducted as part of the risk assessment process. Something to remember is that assets may have more than one threat present against them. A vulnerability assessment is the process of identifying any weaknesses that may be present in the configuration of computing systems, network appliances, and networks. So a vulnerability assessment is a security assessment done on IT assets. Most vulnerability assessments are conducted automatically using specialized software tools called vulnerability scanners. Most vulnerability scanners take a passive approach to the assessment. They are not attacking the system, only trying to identify possible weaknesses in the configuration. That is an important distinction that we will cover in a little more detail in just a bit. There are also different types of assessment techniques. The first one is baseline reporting. And this is the process of using a baseline after an incident has occurred to help determine what may be causing system issues. The baseline is a report on how the system operates under normal conditions, and with baseline reporting, that baseline is compared against what is occurring now. Then there are code reviews. This is having a security tester review and analyze application code developed by in-house programmers before deploying an application. And the key here is that it's reviewed before deploying the application. Attack surface reviews are having a security expert review all of the software and services, which make up the attack surfaces, that are running on any system. The goal is to remove any unnecessary software or services to reduce the attack surfaces that are present. Another assessment is to conduct an architecture review. This is a review of the underlying structure, also known as the architecture, to ensure that all applications and services operate in the correct manner, as in determining that an application does not have access to kernel code, which is not recommended. And finally, there is the design review. It's a careful review of systems and solutions from a security point of view. The design review should be done before the implementation of any system or solution. This is called being secure by design. They should also be conducted after the implementation of a system or solution to help ensure that what was requested or designed was actually implemented correctly. It is time to move on to assessment tools. We will begin with the protocol analyzer, which is also sometimes known as a packet sniffer. It's a tool that will passively collect information on what is traversing the network. It can be used to determine what systems and processes are in operation. One goal of the protocol analyzer, when used for security purposes, is to determine if sensitive information is being transmitted in clear text on the network. Then there are port scanners. It's a tool that will actively scan the network for the status of ports. One goal when used for security purposes is to determine if any vulnerable ports are open. If they're open, they may be easy to exploit. This way, a port scanner can help to find open ports on the network that should be closed. A vulnerability scanner is related to the port scanner, but it is actively searching the system for known vulnerabilities. It will not only check for open ports, but it will also verify configurations and patch levels. It does this by checking the scan results against a database of known vulnerabilities. Banded grabbing is often used with the port scanner and/or with a vulnerability scan type assessment. When used with either of those scans, it will return what software and what version of software it is that is operating on the open port. The information returned can be used to help determine if the open port truly represents a security issue. Honeypots and honey-nets are computing systems or networks established with the sole purpose of attracting any hacker who breaches the network. They have a high level of auditing in place in order to help determine how the hacker entered the system and any actions that the hacker engaged in while within the system. The actual assessment of the results of a hacked honeypot or honeynet is used to further harden the legitimate systems or networks. Some assessment tools are passive and some are active. It is important to know which are which. Passive assessment tools are used to collect information on the network or system, but do not actually attempt to exploit any weaknesses. Active assessment tools do the same thing, but they probe the vulnerabilities to actively determine if they can be exploited. Using an active assessment tool without explicit permission from the organization being examined can lead to being prosecuted. Active assessments are, in actuality, a form of hacking, which the last time I looked is still against the law. That concludes this session on an overview of assessment tools. I began by talking about types of security assessments, and then I concluded with a brief discussion on assessment tools. On behalf of PACE IT, thank you for watching this session, and I hope to do another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on vulnerability scanning versus penetration testing. Today I'm going to be talking about vulnerability scanning and penetration testing, and then we're going to conclude with a brief discussion on levels of testing. And with that, let's go ahead and jump into this session. Of course, I'm going to begin by discussing vulnerability scanning and penetration testing. Vulnerability scanning is usually conducted using specialized applications in an effort to find weaknesses in a network. It is usually conducted using protocol analyzers and port scanners. These applications can be used to determine which protocols and services are being used on a network. Protocol analyzers can also be used to determine which ports are open on a network. This information can be used by security experts to help harden the network against attacks. Vulnerability scanning does not attempt to exploit any weaknesses that are found. It only identifies them for the security personnel. Hopefully, the security personnel will then take care of those vulnerabilities. The purpose of vulnerability scanning is to assess the configuration of systems and networks to determine what can be done to increase the level of security. This is done by passively collecting information and reporting on that information that is collected in a non-intrusive manner. The scan can help to identify different issues, as in lack of security controls. Common misconfigurations in both applications and devices are often found with a vulnerability scan. There are other vulnerabilities that may be recognized, including the use of unsecure protocols or open ports. There are two different types of vulnerability scans that should be conducted, with the results compared with one another. The first vulnerability scan should be done as an authorized user. This is called a credentialed scan, and this should be conducted from an administrative account. So the scan will have complete access to the full system. The other type of scan should be done as an unauthorized user. This is called a non-credentialed scan, and it should be conducted to determine what an unauthorized user may find out about the system. Something to remember about vulnerability scanning is it is possible that a false positive may be returned. A false positive is something that is reported as a vulnerability, but isn't actually a vulnerability. Now, while a false positive may be annoying, it's better than a false negative, which is not reporting a vulnerability that is actually present. Now, that's just downright dangerous. Penetration testing, or pen testing, is actively seeking to find vulnerabilities in networks and systems that can be exploited. Once a weakness is found, the pen tester then attempts to exploit the vulnerability. Many organizations use pen testing as a means of increasing the security of their organizations. Hackers also use pen testing as a means of finding networks and systems that they can exploit. As a result, every security expert must be sure to receive explicit authorization to perform pen testing before beginning the test. If such authorization is not obtained, a security expert could face dire consequences. Unauthorized pen testing is in actuality illegal, as it's a form of hacking. Organizations often perform their own pen testing, or they may contract with a security expert or consulting firm to perform pen testing on their systems. The purpose of pen testing is to assess the security of a system or network by actually using the same methods that a hacker would use to breach security. That includes social engineering. The test can be used to verify that a threat exists, and at the same time, pen testing can also confirm that a threat doesn't exist. The pen test seeks to actively test and bypass any security controls that may be present. It is designed to exploit any vulnerabilities that may be present on the system or network. And again, unauthorized pen testing may lead to legal issues. With that done, let's move on to levels of testing. It is vital that when security tests are conducted on systems and networks, the testing be conducted at a variety of levels, just not at one level. That's not very secure. The first level of security testing should be done at the white box level. White box testing is when the person conducting the test has the exact details of the system or network. The tester has intimate knowledge of what is present and how it is configured. White box testing is often conducted by the person who is developing the system or the network. The next level of security testing is done at the gray box level. With gray box testing, the tester has an intermediate knowledge of how the system or network is configured. A gray box tester is often somebody who is associated with the developer. They may belong to the same group, or they may be developing similar type products. The final level of security testing is done at the black box level. With black box testing, the tester, usually a security expert, is given no prior knowledge of the configuration or what is present in the system. Often, black box testing is contracted out to make sure that the tester has no advanced knowledge of what they're testing. But in all cases, the black box tester should be a security expert. That concludes this session on vulnerability scanning versus penetration testing. I began by discussing vulnerability scanning and penetration testing, and then I concluded with a brief discussion on the levels of testing. On behalf of PACE IT, thank you for watching this session, and I hope to do another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on application security controls and techniques. Today we're going to be discussing secure coding concepts, and then we're going to conclude with some other security controls, techniques, and concepts. I have a fair amount of ground to cover, not a whole lot of time, so let's go ahead and dive into this session. We're going to begin by discussing some secure coding concepts. Hackers will often focus on applications when they are attempting to breach network security. Because of this, application developers need to focus on security controls right from the beginning of developing the application. This is the idea of using secure coding concepts. An application designed with security in mind is much easier to defend than an application that doesn't use such methods. Two of the main concepts of secure coding are error and exception handling and input validation. Thoroughly testing applications during the development process will catch most errors, with the possible exception of some runtime errors. Runtime errors are problems that occur during the operation of an application. Many things can cause a runtime error. They include poor programming, conflicts with other software, including malicious applications, and conflicts with hardware. The developer should put processes in place to trap all runtime errors before such an error crashes the application. Trapping a runtime error requires that the developer intercept the error and display a warning message before the error causes the application to crash. Exception handling is closely related to error handling, except it's a more advanced method of error handling. An exception is just a different term for a runtime error. Exception handling code will use a try-catch block. That means try this code and catch any errors that occur. Usually the try-catch block will provide a means of looping the program until the error condition subsides or goes away. A major cause of runtime errors and other security issues in applications is users inputting invalid data into the application. Secure coding requires that input validation be done before that data is actually placed into the application. Input validation is when the user-supplied data is examined against a set of rules that outline what type of data the application is expecting. If the data received falls outside of the rules, it rejects the input and requests that the user input valid data. One method of testing input validation rules is to use fuzzing. Fuzzing is a process that's used during the testing phase of the application. The developer will input invalid or random data into the input fields in order to test the input validation rules. Now let's move on to some other security controls, techniques, and concepts. Client-side and server-side validation are important concepts to understand. With client-side validation, initial input validation should occur on the client machine, that's the requesting machine, before it is sent to the application on the server. This can help to prevent a runtime error or exploit occurring on the server, and as an added benefit, it reduces the amount of traffic that is crossing through a network. If the input checks valid on the client side, additional input validation should also occur on the server side, that's the receiving machine, before that input is passed on to the application. This further reduces the chance of a runtime error or an exploit. Cross-site scripting prevention is also important. Cross-site scripting occurs when a hacker inserts script code into a form on a website so that when other users access the form, the script is executed. Proper input validation of data is usually an effective means of preventing cross-site scripting from occurring. Then there's cross-site request forgery prevention, or XFRF. XFRF is when a user is automatically directed to a linked web page and logged into that web page using data supplied by a cookie from the original web page, when this was not the web developer's intent. This can happen during a waterhole type attack. Web developers can help to prevent XFRF from occurring by setting a short expiration time for cookies that they use. Users can also help prevent XFRF by choosing not to have a website automatically log them in when they visit that site. Application configuration baseline is the initial setting up of an application, that's the baseline, and it should be done with security in mind. The baseline should be as secure as possible. Another important technique to master is application hardening. This is the disabling of all features and functions that users should not be allowed to access when they are using the application. as in disabling an application's ability to use file transfer protocol. This should initially be done during the configuration or baselining process. Application patch management is another concept that needs to be grasped. New exploits and threats against applications are created all the time, requiring that applications be updated on a regular basis. Patches are used to fix problems, as in security issues, that were unknown at the time that the application was developed. There is a caution though, just as with operating system patches, application patches must be tested before being deployed into a production setting. This will reduce the chances of introducing a new problem or new security issue that might occur if you apply the patch incorrectly. It's important to understand the difference between an SQL and a NoSQL database. SQL databases are the most common relational database management system used today. SQL databases are optimized for the inserting and updating of records in a database. NoSQL databases are designed to store and retrieve large amounts of data. Think big data. They must be optimized for the retrieval of big data and require different methods of input validation than an SQL database. That concludes this session on application security controls and techniques. We began by discussing some secure coding concepts, and we concluded with a brief discussion on other security controls, techniques, and concepts. On behalf of PACE IT, thank you for watching this session, and I hope you watch another one soon. Good day, I'm Brian Farrell, and welcome to PACE IT's session on Mobile Security Concepts and Techniques, Part 1. Today we're going to be talking about mobile device security, and then we're going to conclude with a brief discussion on mobile application security. There's a fair amount of information to go over, so let's go ahead and jump into this session. Of course, I'm going to begin by discussing mobile device security. Since the introduction of the mobile device, loss and theft have been a concern. Just about everyone has either lost a mobile device or had one stolen. In the early years, the major concern was that a cell phone was going to be used to call some foreign country or toll number, and the owner would be stuck with a large bill. Now, with the rise in popularity of smartphones and tablets and the greater portability of data, much more may be at stake. This is especially true with the advent of Bring Your Own Device, or BYOD, policies in the workplace that allow users to use their own mobile devices for work functions. Some mobile device security concepts and techniques that should be used include screen locks. All mobile devices should have the screen lock set. This includes screensavers on laptops. The timer should be set for a relatively short period of time to help safeguard data that resides on that device. Lockout settings should also be enabled. In the case of loss or theft, configuring lockouts will help to prevent unauthorized access to the device. After a specified number of attempts to log in, the device will not allow any further attempts until administrative action is taken, and that administrative action does not occur on that device. Then there are GPS capabilities. Many mobile devices have GPS capabilities, allowing the device to be located if it is lost or stolen. This is an important concept that is used in asset tracking. Asset tracking utilizes GPS capabilities to pinpoint a device's location. And depending upon that device's location, this may lead to remote wiping. Some mobile devices allow for the device to be wiped, that is, all data and applications are removed, and it can do this remotely. This can be used if a device is unrecoverable. Full device encryption should be used whenever possible. Full device encryption will prevent a malicious entity from reading the contents of a device if they steal it. This is especially vital for laptops. A mobile security technique that should be used for device hardening is disabling unused features. Unused features may represent a security risk and should be disabled to prevent their exploitation. In some situations, it may be necessary to disable a mobile device's ability to use removable storage. And this is something that should be covered in an organization's BYOD policies. Application controls are another concept that should be grasped. Many mobile applications attempt to access unnecessary user information, as in they may want to use the location of the device when they start up. Controls should be used to limit the data that applications can access and to restrict actions that applications may undertake with the data that they do have access to. Then there's storage segmentation. Some mobile devices allow for the segmentation of storage, which allows for controls to be put in place to limit how data can be accessed on the device. All organizations should implement inventory control, especially on mobile devices. All mobile devices should be inventoried and tracked. Then there's mobile device management. This is specialized software that is used to manage features that are available on mobile devices. Mobile device management software will also usually have a feature that will remotely wipe a device when given a command. Implement any device access controls that can be used to restrict who can access the mobile device and/or any features on that device that do not comply with the organization's security policies. Now that we've secured the mobile device, let's move on to mobile application security. First up is encryption. Ensure that mobile applications are encrypting sensitive data that is stored on the device. Encryption keys must also be created and stored securely. Then there's credentials management. Security credentials used by applications must be implemented in a secure manner, including storing the credentials in an encrypted format. Whenever possible, a best practice is for the mobile application to authenticate the user and to base access to data on the user's authentication level. A determination needs to be made on geotagging. Some mobile applications store geographical information when they are used. A determination must be made as to whether or not to allow it. Geotagging may present a privacy concern. Some mobile applications allow for whitelisting. This is a list of allowed applications that can access features in the original application. This application whitelisting capability should be managed. Security experts need to make sure that they know what applications have access to other applications. Then there are transitive trust or transitive authentication issues. With transitive trust or transitive authentication, an application will trust an unknown security environment if it is trusted by a security environment that the application trusts. For example, application Z trusts environment T. Environment T trusts environment U. Therefore, application Z will trust environment U. This may or may not represent a security issue, but it should always be examined. That concludes this session on Mobile Security Concepts and Technologies, Part 1. We began by talking about mobile device security, and then we concluded with a brief discussion on some mobile application security topics. On behalf of PACE IT, thank you for watching this session, and I hope to do another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on Mobile Security Concepts and Technologies, Part 2. Today we're going to be discussing the challenges of BYOD, and then we're going to conclude with securing BYOD in the workplace. There's a fair amount of information to go over. We don't have a whole lot of time, so let's go ahead and jump into this session. We're going to begin by discussing some of the challenges of bring your own device. Bring Your Own Device policies, or BYOD policies, allow people to use their own personal devices to conduct official business activities. This does have a benefit for both the business and the people who work there. The business doesn't have to purchase the mobile devices, which saves on expenses. The people who take advantage of BYOD policies get to use their personal devices that they prefer. In addition to that, the people who do use mobile devices no longer need to carry multiples of them. With BYOD policies in place, a person may no longer need to carry 2 cell phones. On the other hand, BYOD policies can represent some special challenges for security personnel and systems administrators that may need to be overcome. What are some of those challenges? Well, the first one is data ownership. When an employee uses their own device, who owns what data can be a challenge. A clear understanding that company data and applications are always company property needs to be achieved. Then there is device support. Before BYOD, the organization was responsible for supporting mobile devices. Support for mobile devices may still be offered by the organization. However, in most cases, the user is the responsible party. This is especially true with smartphones because there are so many different versions of operating systems. IT really doesn't want to have to support all of them. Then there's patch and antivirus management. The organization must determine how it will enforce patch and antivirus management. These can be a critical part of network security. Patch and antivirus management can be achieved through the use of network access control systems, but the mobile device owner may be required to agree to keep the device's patch level and antivirus up to date. Forensics can also represent a challenge for BYOD policies. In order to ensure the security of the organization, the device owner needs to agree that if a security incident occurs, a forensic analysis of his or her device can be done. This can become an issue with privacy. BYOD can also represent some privacy challenges, as in how to ensure the employee's privacy while at the same time keep company data safe and secure. This may become an issue. Most organizations reserve the right to monitor all employee activities, including those activities that take place on mobile devices. This may conflict with personal activities on personal devices. Onboard cameras and video capabilities may also represent a security threat. For security purposes, it may be necessary to require that device owners agree to disable image recording capabilities on their mobile devices. The challenge really comes in ensuring that they do so. BYOD policies also bring in some architecture or infrastructure considerations. The organization's IT architecture and infrastructure may need to be modified to accommodate BYOD. It may require an increase in the IP address range that is made available through DHCP to allow for the growth in mobile devices. Good day, I'm Brian Farrell, and welcome to PACE IT's session on solutions used to establish host security. Today we're going to begin by discussing some techniques for hardening physical hosts, and then we're going to conclude with a brief discussion on hardening virtual hosts. We have a fair amount of information to go over, so let's go ahead and begin this session. We will begin by discussing hardening physical hosts. Often the individual hosts on a network are the target of hackers. It is the resources that they contain that the attackers are after. Because the major purpose of networks is to create a way in which communication and data can flow between systems, they are vulnerable to being breached by hackers. This means that once a breach has occurred, it is vital that all of the hosts on a network be hardened against attack. Hardening hosts is the process of putting technological controls in place that help to ensure the safety and integrity of the hosts, including the data and resources that they contain. There are some basic methods of hardening hosts. The first one is operating system hardening, or OS hardening. This is removing or disabling any unnecessary features and/or services to reduce the OS's attack surface. All features and surfaces will present some type of vulnerability that can be exploited, so they all need to be reviewed and only vital services and features should be enabled. Then there is the operating system security settings. Review all security settings available in the operating system and enable as many of them as make sense to help harden the operating system. As a best practice, do not leave any defaults in place. Defaults are well known and may represent a chink in the operating system's armor. All hosts should have anti-malware installed. Anti-malware is installed to protect against common attacks. The anti-malware application should contain antivirus, anti-spyware, pop-up blockers, and anti-spam features. Another basic method of hardening hosts involves patch management. Ensure that the operating system is kept up to date with current security patches supplied by the manufacturer of the operating system. All software installed on the host should also be part of the patch management program to ensure that those applications don't become a weakness in the system. Additionally, all firmware should also be patched as required. Then there are some more advanced methods of hardening hosts, and the first method is to use a trusted OS. Using an operating system that implements multiple layers of security by design, as in it requires authentication and authorization before granting access to host resources, is an advanced method of hardening hosts. Whitelisting applications can also be done. This is where only applications that are specifically designated in the whitelist are allowed to run on a host. Then there is blacklisting applications. This is the process of explicitly denying or blocking named applications from being able to run on a specified host. An advanced option of host hardening is using host-based firewalls. This is using host-based firewalls to control what network traffic can be allowed into or out of the host. This is especially important for mobile devices, in particular laptops. Host-based intrusion detection systems may also be used. These can be implemented to monitor the host to help detect when an intrusion has occurred to help minimize or contain any damage. And finally, host software baselining can be implemented. Baselining software can be used to ensure that all operating systems and applications on hosts meet or exceed the minimum level of security that is required. Physical security controls can be overlooked when implementing host hardening methods. If an attacker has unfettered physical access to a host, it will not matter how much hardening has been done to the host system. If nothing else, the attacker can just walk away with the asset in order to breach it at his or her leisure. To reduce a hacker's physical access to hosts, some physical security controls should be put in place. Some of the controls that should absolutely be used include locking cabinets for networking equipment and servers. Safes may also be considered for the storage of smaller hosts when they're not in use. And finally, cable locks can also be used to help physically secure hosts from theft. Now it's time to discuss hardening virtual hosts. There are various methods that can be used to help harden virtual hosts, and the first up is the snapshot. A snapshot is an image of a virtual host created at a point in time when that host is secure. A snapshot can be used to quickly revert the virtual host in cases where security has been compromised. Snapshots can also be used to bring up new hosts into service quickly and efficiently as needed, creating elasticity in the system. Patch management also needs to be done with virtual hosts. These have the same considerations as with physical hosts. Then there is host availability. High availability methods should be used to ensure that virtual host systems are available to users as needed, and this is achieved by removing single points of failure. Virtual hosts require different security control testing. That means that separate security control testing should be conducted on virtual systems to ensure that they operate as expected. And finally, there's sandboxing. When high security is needed, a sandboxed environment can be created. This is creating a virtual environment in which the virtual machines are restricted to what they have access to and what can be done with them, meaning that they cannot play outside of their virtual sandbox. That concludes this session on solutions used to establish host security. We began by talking about hardening physical hosts, and then we concluded with a brief discussion on hardening virtual hosts. On behalf of PACE IT, thank you for watching this session, and I hope to do another one soon. Good day, I'm Brian Farrell, and welcome to PACE IT's session on controls to ensure data security. Today we're going to begin by talking about technological controls for data security, and then we're going to conclude with a brief discussion on some unique data security situations. We have a fair amount of information to go over, not a whole lot of time, so let's go ahead and jump into this session. Of course, I'm going to begin by talking about technological controls for data security. As the lifeblood of any organization, data needs to be kept safe and secure at all times. Anytime unauthorized access to data occurs, it can be considered a data breach. A data breach may cost the organization in reputation, revenues, fines may be levied against the organization, or they may lose trade secrets. Because of this, special emphasis is placed on controls for keeping data secure. Something to keep in mind is that data may be in one of three states. It may be in transit, as in it's going from one system to another system. It may be at rest, so that would be when it's on the storage media. Or it may be in use, as in it's being used in an application. In order to ensure the security and integrity of the data, technology controls should be used for all three states. One of the main technological controls used to secure data is data encryption. Whenever possible, data should be maintained in an encrypted format. Encryption ensures that even if a data breach happens, no actual loss of data occurs. Data encryption can be implemented at different places and at different levels. There is full disk encryption. All of the contents of the storage drive are encrypted. In order to access anything on the drive, the proper security keys must be input. There's also database encryption. Sensitive information contained in databases, as in customer credit card numbers or personally identifiable information, should always be kept in an encrypted format. Data encryption may occur at the individual file level. If full disk encryption is not used, then all sensitive files should be encrypted. If removable media is allowed for data storage, then there should be technological controls put in place to encrypt that data when it is on removable media. Then there is mobile device encryption. Because of their nature, all mobile devices that are allowed to contain organizational data should also implement full device encryption. Encryption can also occur at the hardware level. This is called hardware-based encryption. In most cases, hardware-based encryption will outperform software-based encryption solutions. The reason is the chipsets that are used in hardware-based encryption are optimized to perform the necessary algorithmic calculations for the encryption. There are several different types of hardware-based encryption. There is TPM, that's Trusted Platform Module. A specialized chip is used on the motherboard, which, by the way, it must be supported by the BIOS, that contains the cryptographic keys and algorithms that are required to perform the encryption. TPM is very useful for performing full disk encryption on laptops. Then there's HSM, that's Hardware Security Module. A specialized add-on card is installed into the system to perform the hardware encryption. If TPM is not possible, HSM is another option that can be utilized to perform hardware-based encryption. And finally, there's USB and portable hard drive encryption. When data is allowed onto portable media, only devices that support encryption should be used. A solution for USB flash drives is to use an iron key USB flash drive. They are encrypted by default. File and folder permissions are another type of technological control. They're a method for specifying who can access files and folders through authentication and what manipulations can be performed on the data through authorization once it has been accessed. Permissions are usually established through the use of a type of access control list or ACL. Data policies are not necessarily a technological control, but they can be used to help to implement technological controls. Policies, they're usually a form of administrative control, should be put in place that outline the technological controls that detail how data should be handled. The policies should outline at least the following controls. There should be storage controls. These controls, when put in place, determine where and how data may be stored, including the levels of encryption that will be required. Retention policies are controls that are put in place that determine specifically how long data must be kept and maintained and when data must be disposed of. And that moves us to the next one, which are disposal policies. These are controls that are put in place that specify how data must be disposed of. The controls cover both physical and electronic data and should specifically outline the proper disposal method for each type, as in the shredding of physical documents or the sanitation of hard drives. And that brings us to the last of the data policies that should be in place, and that is a wiping policy. These are controls put in place that specify how data on devices that are no longer in use or that are going to be repurposed must be handled. And this is usually through the use of a secure data wiping process. It's time to conclude with a brief discussion on unique data security situations. First up is the Storage Area Network situation, or the SAN situation. Many organizations will utilize the Storage Area Network as a method of storing and accessing data. As most SANs reside on their own networks, controls must be put in place to ensure the security of the communication channel and to keep data secure while it's in transit. There is also the cloud storage situation. Cloud storage does require some special controls in order to keep data secure. In addition to that, in some cases, it is not appropriate to store data on a third-party cloud solution. As in, personally identifiable information, or PII, should never be stored outside of the organization's control. And finally, there's situations involving big data. Big data storage and transmission methods should have special controls put in place to ensure that the communication channels are secure and that sensitive data is maintained in a secure manner at all times. That concludes this session on controls to ensure data security. We began by discussing technological controls for data security, and then we concluded with a brief discussion on unique data security situations. On behalf of PACE IT, thank you for watching this session, and I hope to do another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on mitigating risks in alternative environments. Today we're going to begin by talking about alternative environments, and then we will conclude with a brief discussion on risk mitigation techniques. We have a fair amount of information to go over, so let's go ahead and begin this session. We will begin by discussing alternative environments. As more devices arrive in the workplace with processors built into them, security experts are facing more challenges in securing them. These devices are often considered to be a static environment because the processing power and hardware that the devices comes with cannot be modified or changed. In some cases, exploits have been specifically created to take advantage of the difficulty in securing these environments. Through some careful planning and implementation, some techniques can be utilized to mitigate the risks represented in static environments. The first individual environment that we're going to talk about is the SCADA environment, or the Supervisory Control and Data Acquisition Systems. They are a type of industrial control system that is designed to control large-scale deployments of equipment. The controlled equipment is usually at more than one site. SCADA is often deployed in the energy industry, both on the creation side, so the energy creation side, and on the distribution side, so at your local utility. SCADA tends to have a lack of security on the monitors and controllers that are used to manage the system. Physical security controls should be used to limit access to SCADA components. That is about the best defense for SCADA. Then there are embedded systems. Embedded systems are a self-contained computing system that can be found within a larger system, as in printers, HVAC systems, smart televisions, or even automatic teller machines or ATMs. Often these basic embedded systems lack basic security features or implement weak security. The devices also tend to utilize a very basic version of well-known operating systems. Therefore, you can perform security hardening techniques on those operating systems to help secure these devices. Smartphones represent an alternative environment. Mobile phones are increasingly becoming an important tool in the modern workplace. Due to their increasing capabilities, they are also becoming a greater security risk. Because of their portability, smartphones are subject to loss and theft. Security should be focused on restricting access to data on the phone, and whenever possible, full device encryption should be used. Most modern game consoles can be connected to networks. In many cases, the consoles must be connected to the network in order to take advantage of gaming features. Security features for gaming consoles have been increasing lately, so therefore the best mitigation technique is to ensure that all updates are in place for any gaming console that is placed on a network. Mainframes are high-cost, powerful computing systems that contain significant processing power. Due to their cost, mainframes are not replaced very frequently and may be using an older version of operating systems, which may have well-known vulnerabilities. Technological controls should be in place to help secure mainframes. Firewalls, access control lists, and door locks can all be implemented to restrict access to the mainframe environment. And finally, we have in-vehicle computing systems. Car manufacturers have been using processors in vehicles for many years. Initially, the processors had limited capabilities and could prove difficult to exploit without physical access to the vehicle. Modern vehicles are coming with more connected systems that may represent a challenge to security. As a matter of fact, in July 2015, a security team demonstrated the ability to take over a vehicle's systems remotely, including the ability to take control of the braking system and the ability to accelerate. and they did this from approximately 10 miles away. At this point in time, I am unaware of any mitigation technique for this risk. And with that, let's move on to a brief discussion of some risk mitigation techniques. First up is segmentation. Segmentation is a network design element in which the resources are separated, and they can be separated by function and security requirement, into their own networks. This can be used to control communication and security within the network. Another risk mitigation technique is security layers. Placing security at different places and levels within a network will increase the security of the network as a whole. If one layer of security is breached, attackers will find another layer waiting to frustrate them, like the layers of an onion. Hopefully it makes that hacker cry at each layer that they get to. Application firewalls may also be used. Application firewalls can be used to filter traffic based on what applications are allowed to operate on the network and which applications are not allowed to operate on the network. Updates are another risk mitigation technique. Patches and systems updates should be used to help keep computing environments secure. A best practice is to use a manual updating process so that proper testing of the updates can be done before they're placed into a production environment. Firmware version control should also be implemented. Updates to firmware should be done if it will lead to an increase in security or in vital functionality. And then we have wrappers. These are also known as TCP wrappers. It's a host-based access control list or host-based ACL that can be used in conjunction with a firewall to increase the effectiveness of security. Wrappers can be found in Linux and Unix environments and can be used to specify how an individual host can access a specific service. As in, you can use TCP wrappers to allow Bob access to secure copy protocol, but not to file transfer protocol on the file server. When implementing a layered security mitigation technique, it is important to use a variety of products. If all of the firewalls used in the layered approach are the same product, then they will more than likely all have the same vulnerability. Once an attacker breaches one firewall, the rest will likely fall in short order. A best practice is to implement a diversity of products for security considerations, as in using different firewall devices at the different layers. If different products are used, then the hacker has to figure out how to get past each individual product, and the attacker cannot rely on the same vulnerability being present in each device. Now that concludes this session on mitigating risks in alternative environments. We began by talking about those alternative environments, and then we concluded with a brief discussion on some risk mitigation techniques. On behalf of PACE IT, thank you for watching this session, and I hope you watch another one soon. Good day, I'm Brian Farrell, and welcome to PACE IT's session on a summary of authentication services. Today we're going to be discussing the function and purpose of authentication services, and then we will conclude with a brief discussion on some authentication services. There is a fair amount of information to cover, so let's go ahead and dive into this session. Of course, I'm going to begin by discussing the function and purpose of authentication services. A best practice in network security is to require authorization when access is desired, either to the network or resources on the network. Authentication services are basically the first step in the authorization process. Authentication services require requesters to prove that they are who they say they are by the submission of some type of credentials, as in username and password. The authentication service then examines the credentials against a database of valid credentials. The database contains information on which credentials the authentication service will accept. If accepted, one of two things occur. Either the authorization is granted, or the authentication service passes the approved credentials onto an authorization service. With that covered, let's move on to authentication services. Authentication services may be part of a AAA protocol. AAA stands for Authentication, Authorization, and Accounting. AAA protocols will validate the credentials of the requester, that's authentication. They will then grant access to resources, that's authorization, and then log the requester's activity, as in what they do. That's the accounting service. All of these separate functions can be combined into a single protocol. In other cases, the individual services are actually separated. In this situation, the services will be set up in a manner in which they will pass information back and forth in order to form a holistic, secure environment. Now let's move on to some specific authentication services. First up is Radius, Remote Authentication Dial-In User Service. That's Radius. It's a remote access service that is used to authenticate remote users and grant them access to authorized network resources. It is a popular AAA protocol used to help ensure that only authenticated end users are using the network resources they are authorized to use. Radius has very strong and robust accounting features, but only the requesters, that's the end users, password is encrypted. Everything else that flows through Radius is sent in clear text. Then there's TACACS Plus. That's Terminal Access Controller Access Control System Plus. That is a mouthful. That's why we say TACACS Plus. It's a remote access service that is used to authenticate remote devices and grant them access to authorized network resources. It is a popular AAA protocol used to help ensure that only authenticated remote network devices are using the network resources they are authorized to use. The accounting features are not as robust as those found in Radius, but with TACACS Plus, all transmissions between devices are encrypted. In most cases, Radius is a AAA protocol used for users, while TACACS Plus is a AAA protocol used with devices. Then there's Kerberos. It's an authentication protocol which uses TCP or UDP on port 88. It's a system of authentication and authorization that works well in environments that have lots of clients. There are several different components to Kerberos. The Key Distribution Center, or KDC, is the main component. The KDC has two parts: the Authentication Server, or AS, and the Ticket Granting Service, or TGS. When a user logs in, a hash of his or her username and password is sent to the authentication server. If the AS likes the hash, it responds with a Ticket Granting Ticket, TGT, and a timestamp. The client then sends the TGT with the timestamp to the Ticket Granting Service. The TGS responds with a service ticket. This service ticket can also be called an access token, or sometimes it's known as just a token. The service ticket authorizes the user to access specific resources. As long as the ticket granting ticket is still valid, the TGS will grant authorization by issuing a new service ticket. Lightweight Directory Access Protocol, or LDAP, is another popular authentication service. It's a directory service protocol that can be used to authenticate clients. LDAP requests are sent over TC port 389. Applications that are LDAP compliant will validate or authenticate the client and then retrieve the requested information that is stored in the directory. There's another version of LDAP out there that's called Secure LDAP. It's an encrypted version of LDAP using Secure Socket Layer, or SSL, over TCP port 636. All communication between the client and LDAP is encrypted and is secure. And finally, there is SAML, Secure Assertion Markup Language. It's an XML or extensible markup language standard that is used to allow systems to exchange authentication and authorization information. Now that concludes this session on a summary of authentication services. We began by talking about the function and purpose of authentication services, and then we concluded with a brief discussion on some specific authentication services. On behalf of PACE IT, thank you for watching this session, and I hope to do another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on Authentication and Authorization Basics, Part 1. Today we're going to begin by talking about identification, authentication, and authorization, and then we're going to conclude with a brief discussion on some authentication concepts. I have a fair amount of information to go over, not a whole lot of time, so let's go ahead and begin this session. We will begin by talking about identification, authentication, and authorization. Three basic security concepts that are tied together are identification, authentication, and authorization. Identification is when an entity specifically declares who or what it is in a manner in which the receiving party understands. When the entity is a person and the receiving party is a computer, the most common form of identification is a username. Authentication is a process where the identifying party offers some form of credentials to validate the identification, as in supplying a password with the username. Authorization is what the authenticated entity is allowed to access or the actions that may be taken by that authenticated entity. As in authorization to access the FTP server and modify files on that same server. That would require authorization. There are some common identification methods. The first one is the username. Usernames should be unique to the system that is being accessed. There are also personal identification verification cards, which are usually issued by an accepted authority, as in the U.S. government or a state government or the organization that is accepting the identification. A personal identification verification card may also contain information on authentication, as in it may contain information on biometric values of the user. Another common form of identification is biometrics. It is a physical trait that is unique to the individual that is difficult to modify or change, as in a fingerprint. When using an authentication service, they usually require some form of authentication factor. There are some common authentication factors that are used. There is the something you know, as in a username and password. There's the something you are, as in biometric patterns. Something you have, as in a security token or smart card. A newer authentication factor is the something you do, as in a repetitive typing pattern. Those can be as unique as a fingerprint. And finally, there is the somewhere you are, as in the GPS location or IP address that is requesting access. It's time to conclude with a brief discussion on some authentication concepts. First up is multi-factor authentication. This is requiring more than one of the authentication factors to be present before the authentication process can be completed. Multi-factor authentication is more secure than just requiring a single one of the factors. A username and password is a single-factor authentication method, as both of those come from the something you know category. Multi-factor authentication requires that the factors come from different categories. So requiring a username, password, and a fingerprint scan is a two-factor authentication method. Those come from the something you know category combined with the something you are category. Then there is single sign-on, or SSO. This is requiring the user to identify and authenticate only once to achieve access to all authorized services within a network. In the past, every time a user needed to access a different resource, that resource was required to authenticate the user before authorizing the access. This took time and did create some network congestion. Single sign-on will reduce the network traffic that is required and will also speed up the process. Identity federation. This is an SSO method used in organizations with multiple networks that allow authenticated users to sign on once and receive access to authorized resources across all of the organization's networks. In some cases, identity federation may rely upon transitive trust authentication. This is the process of authenticating an entity based on that entity already being authenticated by a security entity that is trusted. For example, X is authenticated by organization T, but is requesting authentication from organization A. A doesn't know X. Since organization A trusts the security of organization T, A will authenticate X automatically. That is transitive trust authentication. There is access control. This is the process of establishing specifically who or what can be authenticated and how that authentication will be done before authorization is granted to resources. Another authentication concept is the implicit deny. All access is automatically denied through the implicit deny until the authentication process has been completed. And finally, there is the trusted OS, or trusted operating system. This is used to denote an operating system that uses multiple layers of security before access is granted to resources on the system. So a trusted OS will implement authentication and authorization before granting access to resources on that system. Now that concludes this session on Authentication and Authorization Basics, Part 1. I began by talking about identification, authentication, and authorization, and then we concluded with a brief discussion on some authentication concepts. On behalf of PACE IT, thank you for watching this session, and I hope you watch another one soon. Good day. I'm Brian Farrell, and welcome to PACE IT's session on Authentication and Authorization Basics, Part 2. Today we're going to begin by covering some authentication concepts, and then we will conclude with a brief discussion on some authorization concepts. We do have a fair amount of information to go over, not a whole lot of time, so let's go ahead and jump into this session. Of course, I'm going to begin with a discussion on some authentication concepts. A common method of authentication involves creating a hashed value of the information. Hashing is a cryptographic process that uses an algorithm to derive a set value, that's the hashed value, from data and a secret key. The hash can be used to verify that the data is coming from where it is supposed to and that it has not been intercepted or changed in transit, thus providing both authentication and an integrity check at the same time. The most popular hashing algorithms are MD5, that's Message Digest Algorithm 5, and SHA-1, that's Secure Hash Algorithm 1. Of those two hashing algorithms, SHA-1 is the more secure, and if security is your main concern, it's the one that should be used. Some additional authentication concepts include HMAC, that's Hash-Based Message Authentication Code. This is where a secret key is combined with an algorithm to create the Message Authentication Code, or MAC. The MAC is actually the resulting hashed value. It's the end result. Then there is the hash-based one-time password, or HOTP. It is an HMAC-based algorithm that is used to create the password that is used for authentication purposes. HOTP is often used by authentication servers. Then there's TOTP. That's time-based one-time password. It's an authentication process for creating passwords based on the current time. An algorithm is combined with a secret key and the current time to generate a one-time password. It is a type of HOTP. TOTP is commonly used with security tokens that are used for two-factor authentication. PAP, or Password Authentication Protocol, is a basic form of authentication. When logging into a network resource, the user or device is required to supply a username and password. The username and password are sent in clear text format, so this method is considered unsecure and should only be used as a last resort. More secure than PAP is CHAP, that's Challenge Handshake Authentication Protocol. When logging into a network resource, the user or device is challenged to supply a user and secret password, and it authenticates through a three-way handshake process. The resource issues a challenge. What is the hashed value of the username and secret password? So what is the HMAC? The user's device sends the hashed value to the resource device. The resource evaluates the hashed value against a database and either accepts or rejects the connection. Then there is the token. Tokens utilize a time-based one-time password to authenticate users via two-factor authentication. The TOTP is usually generated every 30 to 60 seconds. The token may be hardware-based, as in it's attached to a key fob, or the token may be software-based, as in it's supplied by an app on a smartphone. Then there are smart cards. Smart cards can also be used for authentication. They utilize a card, usually credit card sized, that has an embedded circuit and a personal identification number or PIN number is used, and smart cards also provide two-factor authentication. Then there is the Common Access Card, or CAC. It's a type of smart card issued by the U.S. military that is used for identification and authentication purposes. It is used to authenticate users on military networks. It is also used to encrypt and digitally sign electronic messages. Now let's move on to authorization concepts. The first authorization concept we're going to cover is separation of duties. This is the process of taking a critical organizational task and separating it into smaller jobs. No one person is allowed or authorized to perform all of the duties that make up the task, thus reducing the risk that can arise from a malicious employee. Then there is principle of least privilege. This is only granting the minimum amount of rights and privileges, or authorization, that are required for employees to perform their jobs. This also reduces the risk associated with either malicious employees or a compromised user account. Then there are time of day restrictions. This is establishing technological controls that limit what actions may be taken based on time, as in preventing employees from logging on to the network outside of operating hours. Rule-based access control, or RBAC, may be used by authorization systems. Rule-based access control is the creation of rules within a system that either allow or disallow authorization to perform actions based on the rule. The ACL, or Access Control List, tends to be a type of rule-based access control, and it is used for authorization purposes. Typically, it comes in the form of a list of rules. The list is typically examined from top to bottom. Once a rule is matched, the corresponding action is taken. If no rule is matched, the typical response is to deny authorization. Then there is role-based access control, which unfortunately is also called RBAC. It's a process of creating authorization levels based on the role, as in user group, that a person fulfills within an organization. Different roles will have different authorization levels, allowing the people who fill those roles to perform different duties. It It is most often implemented using the principle of least privilege. Then there is discretionary access control, or DAC. It's a technological control that is used to determine authorization to resources based on a specific list. The list is called the Discretionary Access Control List, or DACL. The DACL is a listing of users and groups that are granted access or authorization to resources. The DACL will also determine the amount of access, or what actions can be taken based on permissions, that the user or groups has to that specific resource. And finally, we have the Mandatory Access Control concept, or the MAC concept. It's an access control model in which each individual, which are known as subjects, are assigned to a clearance level, as in top secret or confidential. Authorization to resources is based on the resource's classification, as in, is that resource top secret or confidential? The subject is usually granted automatic authorization for resources that are at or fall below their clearance level. As in, a top secret clearance will always be able to access resources classified as secret. That concludes this session on Authentication and Authorization Basics, Part 2. We began with some authentication concepts, and then we concluded with a brief discussion on authorization concepts. On behalf of PACE IT, thank you for watching this session, and I hope to do another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on the Introduction to Cryptography, Part 1. Today we're going to be starting with cryptographic services, and then we're going to conclude with a brief discussion on encryption basics. There's a fair amount of information, not a whole lot of time, so let's go ahead and jump into this session. Of course, I'm going to begin by discussing cryptographic services. Cryptography is the process of deriving a code value from a set of data. An example of this is taking a clear text message and creating a ciphertext message. That is, a message that can't be easily read. Cryptography is also the process of decoding the ciphertext message to obtain the clear text message, so the reverse process is also part of cryptography. Cryptography offers three basic services: encryption, hashing, and authentication. It's time to begin a discussion on encryption services. This is the process of taking a clear text message or set of data and scrambling it through the use of a cipher. That's an algorithmic process. Encryption services are used to secure messages and data sets against theft or loss, including its interception while the data is in transit. There are different types and methods of encryption that can be used. Hashing is the process of taking a set of data and using an algorithmic process to generate a value that only the original data value can generate. This generated value is known as the hashed value or message digest. The hashed value is generated and is appended or added to the data, and it is used to ensure the integrity of the data. If the data with the hashed value is sent to another party, that party can use the same hashing algorithm on the data and compare the two hashed values. If the two hashed values match, the integrity is ensured. Cryptography is also used for authentication services. Authentication is a cryptographic method used to prove that the creators of messages are in fact who they say they are. Authentication is used for non-repudiation purposes. The person sending the message, once authenticated, cannot claim that the message did not come from him or her. This authentication usually is achieved through the use of digital signatures. It's time to discuss encryption basics. Encryption algorithms work by using a key to scramble the data, or message, so that if the data is intercepted, it can't be easily read. To unscramble the data, the process is reversed. Encryption algorithms are either symmetrical or asymmetrical in nature. With symmetrical encryption algorithms, both sides of the communication use the same key to encrypt and decrypt the data. With asymmetrical encryption algorithms, one key is used to encrypt the data and a different key is used to decrypt the data. The key that encrypts the data cannot be used to decrypt it. Asymmetrical encryption is much more secure, but it also requires more management and computing resources. Often, asymmetrical cryptography is used to establish a symmetrical encryption method. Encryption requires the exchange of security keys. In order for encryption to function between different entities, the proper security keys must be used, as in the keys must be exchanged between the communicating parties. The key exchange may occur in-band, as in part of the actual communication session, or the key exchange may occur out of band, outside of the data communication channel. For example, sharing the encryption key over the phone and then sending encrypted data over the internet. There are several different types of security keys, and they can be further broken out by the type of encryption that's used. There are symmetrical encryption key types. There is the pre-shared key, or PSK. The encryption key is shared before the communication session starts, usually through an out-of-band key exchange. A PSK can also be called a secret key or a private key. Then there are session keys. This is a random key that is generated during the communication session, and it's a type of in-band key exchange. Then there is the asymmetrical encryption key type. The most common method uses a public key and a private key system, referred to as a public key infrastructure, or PKI, to manage the different security keys. And in most cases, PKI is implemented through an in-band key exchange. There are also different types of encryption methods. Some encryption algorithms are a stream cipher algorithm. The encryption occurs one bit at a time. The encryption process is fast, and if an error occurs, it will usually only affect a single bit. Then there are block cipher algorithms. The encryption takes place on predetermined blocks of data, as in at 64 bits of data at a time, or on 128 bits of data at a time. The encryption process is slower and more error-prone, but is considered to be more secure than the stream cipher type. There is steganography. This is the process of encoding or concealing data within a graphic file. The person receiving the graphic file must use steganography software to read the secured data. Steganography can be used to place an encoded message on a graphic image on a website that the recipient can then retrieve and decode. Transportation encryption may be required. It may be vital that certain information flowing across public networks, as in the internet, be kept secure during the transportation process. It may also be wise to provide security when using communication channels on a private network. Some specific protocols have been developed to help secure transportation communication channels. HTTPS is one of them. That is Hypertext Transfer Protocol Secure. It's used to encrypt communication between a web server and a client. HTTPS will utilize either SSL or TLS to provide the encryption. So let's talk about SSL and TLS. That is Secure Socket Layer and Transportation Layer Security. These are used to encrypt communications channels, usually at the transportation layer, or layer 4 of the Open System Interconnection Model, or OSI model. Of the two, TLS is more secure than SSL. Then there's SMIME, that's Secure Multipurpose Internet Mail Extension. It's used to encrypt email messages between parties. And finally, there's IPsec, Internet Protocol Security. It's actually a suite of protocols that are used to authenticate users and encrypt the communication channel. That concludes this session on the Introduction to Cryptography, Part 1. We began by talking about cryptographic services, and then we concluded with a brief discussion on encryption basics. On behalf of PACE IT, thank you for watching this session, and I hope to do another one soon. Good day, I'm Brian Farrell, and welcome to PACE IT's session on Introduction to Cryptography, Part 2. Today we're going to begin by discussing some hashing basics, and then we're going to conclude with a brief discussion on some additional cryptography topics. We have a lot of information to go over, not a whole lot of time as usual, so let's go ahead and begin this session. We will begin by discussing some hashing basics. The idea behind hashing is to create a method of easily verifying the integrity or authenticity of a set of data. The process involves using an algorithm on the data to create a unique value that can be used to verify the dataset. This value is known as the hashed value or message digest, and no matter how many times the dataset is run through the hashing algorithm, the same hashed value is derived. That is, as long as the same algorithm is used. The message digest can also be known as a one-way hashed value. This is because it is impossible to take a hashed value and determine what the data is. This helps to keep the data secure and provides an integrity check. Let's discuss some hashing concepts. Hashing algorithms only work on data. They do not work on the headers of a file. No matter how many times the header of the file changes, as in changing the name of a file, the hashed value of the data remains the same. The hashed value returns a fixed length that depends on which algorithm is used. A specific algorithm will always generate the same size hash. It is theoretically possible to recreate a hashed value by running enough data through the hashing algorithm. That's kind of that infinite monkeys and the Shakespeare concept. When two hashed values are the same, it is called a collision, and that actually signifies that that hashing algorithm is broken. The collision concept is the idea behind a birthday type attack. Then we have HMAC. Hash-based message authentication code. This is the process of using a secret key, which is a data value only known to the communicating parties, combined with the dataset to derive the hashed value. And that hashed value actually makes up the message authentication code portion of HMAC. HMAC provides an authentication check verifying the identity of the sender, as well as an integrity check of the data. Some common hashing algorithms include MD, that's Message Digest. It was created by Ron Rivest. MD5 is the current standard used when using the Message Digest algorithm and always returns a 128-bit hashed value. As a side note, the MD5 algorithm is considered to be broken and should only be used in a limited way. The other most common hashing algorithm is SHA, that's Secure Hash Algorithm. It was created by the National Security Agency, also known as the NSA. SHA-1 is the most popular version of SHA and always returns a 160-bit hashed value. There is also SHA-256, and that version always returns a 256-bit hashed value. And finally, there is SHA-512. It is also a newer version of SHA that returns a 512-bit hashed value. It's time to conclude with a brief discussion on some additional cryptography topics. First up is key escrow. This is the process of storing or giving encryption keys to a third party. The third party can then use those keys to decrypt any messages that those keys use. In some cases, governmental agencies have required the turning over of encryption keys to aid in investigations. Key escrow is a highly controversial topic. Most organizations that deal with encryption and cryptography do not like the concept of key escrow. Then there is ephemeral key. It is a temporary key that is used to encrypt a single message within a communication channel. Ephemeral key reduces the chances that a hacker will acquire a key set and be able to decrypt the message. Ephemeral key is used in perfect forward secrecy. This is a process that generates a random public key or ephemeral key for each session so that the private key exchange can be kept secure. In cryptography, there is the concept of a digital signature. Digital signatures are created to digitally sign messages in order to prove the integrity of the sender. A message digest or hashed value is created from a set of data and then encrypted with the sender's private key. The receiver decrypts the hashed value with the sender's public key and then verifies the hashed values. That is how digital signatures work. Digital signatures also provide a means of non-repudiation. The sender can't deny that he or she is the entity that sent the message because it was encrypted with their private key. Then there is elliptic curve. It's a newer asymmetrical encryption algorithm that employs the Diffie-Hellman algorithm for the exchange of keys and the digital signature algorithm, or DSA, for the digital signatures. And finally, there's quantum cryptography. It's an encryption standard that is used with fiber optic communication to determine if the message has been intercepted. It relies upon the fact that any interaction with the photons in transit will cause the state of the photons to change and therefore indicate that that message has been intercepted. That concludes this session on Introduction to Cryptography, Part 2. We began by discussing some hashing basics, and then we concluded with a brief discussion on some additional cryptography topics. On behalf of PACE IT, thank you for watching this session, and I hope you'll watch another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on Cryptographic Methods, Part 1. Today we're going to begin by discussing cipher suites, and then we're going to conclude with a brief discussion on some cryptographic implementations. There's a fair amount of information, so let's go ahead and begin this session. Of course, I'm going to begin by discussing cipher suites. In most cases, a single cryptographic method will not provide the required level of security that most organizations seek. The solution is to use a cipher suite to provide the necessary security. A cipher suite is when a group of cryptographic solutions are combined to provide user authentication, encryption, and message authentication solutions into a single set. One measure of the strength of the cipher suite is the number of bits that make up the keys. The longer or more bits the key set, the stronger the cipher, which will lead to a stronger cipher suite. One thing to remember, the stronger the cipher suite, the more computing power and time it will take when that cipher suite is in use. So it becomes a balance between the strength of the cipher and the computing resources that are on hand. Let's conclude with a brief discussion on some cryptographic implementations. First up is PAP, Password Authentication Protocol, which is actually not a cryptographic implementation. It's an authentication protocol that does not use any cryptographic method to ensure the integrity of the message. The username and password are sent in clear text, and this is not a secure solution. Password authentication protocol should only be used when all other cryptographic methods are not possible. Then there is CHAP, Challenge Handshake Authentication Protocol. It's a cryptographic authentication protocol used to authenticate remote clients based on hashed values. The client device, the one requesting authentication, combines its password with a key supplied by the server to generate a hashed value. MD5 is the algorithm used to generate that message digest. The client sends the hashed value, or message digest, back to the server, which then compares what was received against a stored value, so a stored version of that hashed value. If the values match, the client is authenticated and then given access to authorized resources. CHAP is considered to be a type of HMAC, that's hash-based message authentication code. RIP-EMD, or Race Integrity Primitives Evaluation Message Digest, is another cryptographic implementation. It is a cryptographic hashing algorithm developed as an open source solution. When implemented, the most common version is RIP-EMD 160. It uses a 160-bit hashing function. Then there is NTLM version 2. Or NetLAN Manager version 2. It's a cryptographic hashing process used in Microsoft Windows operating systems for the storing of passwords in the registry as hashed values. So the actual password is not stored in the registry, only the hashed value. NTLM version 2 uses HMAC MD5, that's HMAC using Message Digest 5, as the method of creating and storing the message digest. It replaced the original version, which was NTLM, which used MD4 as the hashing algorithm for the HMAC. So let's discuss the message digest algorithm, or the MD algorithm. It's a cryptographic hashing algorithm developed by Ron Rivest as a method of using hashed values for authentication purposes, particularly to ensure that the data that is received is the data that was sent. MD5 is the most popular version and always generates a 128-bit hashed value. While still in use, MD5 has been proven to be a broken cryptographic solution and should not be used for mission-critical security needs. A better solution is SHA, or Secure Hash Algorithm. It's a cryptographic hashing algorithm developed by the NSA, or National Security Agency, as a method of using hashed values for authenticating data, that is, to ensure the data's integrity. SHA-1 is the most popular version and always generates a 160-bit hashed value. In theory, SHA-1 has been broken. I say in theory because the weakness has yet to be proven, but most U.S. government agencies now require the use of SHA-2 in place of SHA-1. SHA-2 is an improved version of the original SHA family of hashing algorithms. That concludes this session on Cryptographic Methods Part 1. We began by discussing cipher suites and concluded with a brief discussion on cryptographic implementations. On behalf of PACE IT, thank you for watching this session, and I hope you watch another one soon. Good day, I'm Brian Farrell, and welcome to PACE IT's session on Cryptographic Methods Part 2. Today we're going to have a brief discussion on key stretching, and then we're going to conclude with a discussion on some cryptographic implementations. I have a fair amount of technical ground to cover, not a whole lot of time, so let's go ahead and begin this session. Of course, we're going to begin with a brief discussion on key stretching. The greatest vulnerability in any cryptographic implementation tends to be in the security key that is used in the process. In many cases, the security key is either a password or passphrase that is used in the cryptographic process. Both passwords and passphrases are susceptible to brute force type attacks, leading to a weakness in the cryptography that's used. The solution to this is to use a process called key stretching or key strengthening to harden the keys against brute force type attacks. With key stretching, the password or passphrase is processed by an algorithm to strengthen the password by increasing the complexity of the key. Two popular algorithms used for key stretching are bcrypt and PBKDF2, that's password-based key derivation function 2. Now that we've covered key stretching, let's move on to cryptographic implementations. First up is the one-time pad. It's a symmetrical cryptographic encryption method in which a random security key is used to encrypt a message only one time. It is particularly resistant to hacking, as the key will change with every message that is sent. When the random key used is the same length as the message, it is even more difficult to break. Another cryptographic implementation is DES, Data Encryption Standard. It's a symmetrical cryptographic encryption standard developed by the U.S. government. It is a block cipher, so it encrypts complete blocks of data at a time, and it utilizes a 56-bit encryption algorithm. DES is not considered to be secure. Triple DS is an improvement on DES that utilizes 3 separate 56-bit encryption keys to create a 168-bit encryption method. Each block of data is encrypted 3 times, once for each of the security keys. Then there is RC, which stands for the Rivest cipher. It's a family of symmetrical cryptographic encryption methods developed by Ronald Rivest. RC4 is a stream cipher, so it encrypts 1 bit at a time, used by other cryptographic solutions, including SSL, Secure Socket Layer, and WEP, WEP, Wired Equivalent Privacy. It is considered to be a weak encryption standard and should no longer be used. RC5 is a block cipher algorithm that is much more secure than RC4. Then there's Blowfish. It's a symmetrical cryptographic encryption method developed by Bruce Schneier as a replacement for the weaker DES standard. It utilizes a variable encryption bit length and can offer anywhere from single-bit encryption to 448-bit encryption. While Blowfish can be effective, it can also be difficult to work with. Twofish is a symmetrical cryptographic encryption method developed by Bruce Schneier based on his development of Blowfish. Twofish utilizes 128-bit encryption and is easier to work with than Blowfish. And then there's AES, Advanced Encryption Standard. It's a symmetrical cryptographic encryption method developed on behalf of the National Institute of Standards and Technology, that's NIST, which is an agency of the U.S. government. It is a block cipher encryption method in which the block size is always 128 bits, but the key used for the encryption can be 128 bits, 192 bits, or 256 bits. AES has been adopted worldwide as an acceptable level of encryption and performance. RSA is an asymmetrical cryptographic encryption method that is named after the developers. It is the first widely used encryption standard to employ the use of public and private security keys. An entity's public key can be used by anyone to encrypt messages. Only the entity's private key can be used to decrypt messages encrypted by the public key. PGP, also known as Pretty Good Privacy, is an asymmetrical cryptographic encryption method that can be used to generate security keys and to publish the public security keys in a secure manner. It allows for the secure, think encrypted, use of email between 2 endpoints with minimal effort. GPG, also known as GNU Privacy Guard, is a GNU systems implementation of PGP. GNU is a Unix-like operating system, and Linux is part of the GNU family of operating systems. One issue with asymmetrical encryption is how the exchange of security keys is going to occur in a secure manner. The first practical solution was developed by Whitfield Diffie and Martin Hellman. Their solution was referred to as the Diffie-Hellman, or DH, key exchange. It created a secure method in which 2 unrelated parties could jointly create a shared secret key over an unsecure communication channel, as in the Internet. Diffie-Hellman has since been improved upon with the creation of DHE and ECDHE. DHE stands for Diffie-Hellman ephemeral key, and ECDHE stands for elliptic curve Diffie-Hellman ephemeral key. Both DHE and ECDHE help to provide perfect forward secrecy and help to ensure the security of the key exchange process. That concludes this session on cryptographic methods part 2. I began with a brief discussion on key stretching, and we concluded with a discussion on cryptographic implementations. On behalf of PACE IT, thank you for watching this session, and I hope to do another one soon. Good afternoon, I'm Brian Farrell, and welcome to PACE IT's session on Introduction to Public Key Infrastructure, Part 1. Today we're going to begin with an overview of asymmetrical encryption, and then we're going to conclude with a brief discussion on certificate authorities and digital certificates. With that, let's go ahead and jump into this session. We will begin with an overview of asymmetric encryption. In asymmetric encryption, two separate cryptographic keys are used to encrypt data. The two keys are mathematically linked through special algorithms. One key can encrypt the data, the other key is then used to decrypt the data. The key that encrypts cannot decrypt, and the key that decrypts cannot encrypt. If the parties in the communication are not closely associated with each other, an issue arises on how to securely exchange security keys. Asymmetric encryption requires more computing resources than symmetrical encryption methods. Often, an asymmetrical encryption session is used to establish a trust relationship between two entities. It's a verification that the parties are who they say they are. Once the verification has taken place, the parties then agree upon a secret key that can be used with an agreed-upon symmetrical encryption standard. This reduces the computing overhead required for communication. In many situations, asymmetrical encryption revolves around a public key infrastructure, or PKI. PKI is a process that is used to generate and manage the two security keys that are necessary for asymmetrical encryption. With PKI, two keys are created, a public key and a private key. The public key is made known and is readily associated with a specific entity, as in the public key is known to belong to either a person or an organization. That same entity is responsible for maintaining the security and integrity of the private key. Messages encrypted with the public key can only be decrypted with the private key, thus ensuring the security of any message. PKI is established with the assistance of a certificate authority. With that, let's move on to certificate authorities and digital certificates. There are different types of certificate authorities. The first one is the public CA. It's a third-party entity that is in the business of issuing, as in selling, the digital certificates that are used with PKI. A public CA is useful when there is not an existing trust relationship between two parties that require the use of asymmetrical encryption. Many applications automatically trust certificates issued by public CAs, as in Internet Explorer or Firefox automatically trust certificates issued by a CA like VeriSign or GoDaddy. The public CA has the power to revoke an entity's digital certificate in cases of fraud or a security breach. Then there is the private certificate authority or private CA. This is the process that is used when an organization creates its own PKI. The organization self-signs its own digital certificates that are used to support asymmetrical encryption. An advantage to the private CA is that the organization doesn't need to pay for each individual certificate. A disadvantage to the private CA is that it may be difficult to get other organizations to accept those self-signed digital certificates. There are different levels of certificate authorities. The PKI model requires that there be a hierarchical structure to the certificate authorities. The first CA to be installed in PKI is the root certificate authority. The root CA issues digital certificates to all other CAs that are installed in the PKI model. These additional certificate authorities are called subordinate CAs. By default, the root CA must self-sign its own certificate. Digital certificates are an electronic file that is used to store the public key of the entity that the certificate is issued to. The digital certificate is bound to and uniquely identifies the entity that it is issued to, which eases the asymmetrical encryption process used by PKI. There are some key components to the digital certificate. There is the public key. This is the public encryption key of the entity that the certificate was issued to. There is the serial number. It's a unique number assigned to the certificate to help identify it. The algorithm field is the asymmetrical algorithm used by the certificate. The subject field identifies the entity that was issued the certificate. Issuer is the entity that issued the certificate. The valid from and valid to fields indicate when the certificate was issued and when it expires. The thumbprint algorithm field identifies the hash algorithm to use when verifying the integrity of the certificate, and then the thumbprint field is the actual hashed value of the certificate, which can be used to verify that the certificate has not been altered. That concludes this session on Introduction to Public Key Infrastructure, Part 1. We began with an overview of asymmetric encryption, and we concluded with a discussion on certificate authorities and digital certificates. On behalf of PACE IT, thank you for watching this session, and I hope you'll watch another one soon. Good day, I'm Brian Farrell, and welcome to PACE IT's session on Introduction to Public Key Infrastructure Part 2. Today we're going to begin with a discussion on certificate authority responsibilities, and then we will conclude on some additional public key infrastructure concepts. I have a fair amount of ground to go over, not a whole lot of time, so let's go ahead and begin this session. Of course, I'm going to begin by discussing certificate authority responsibilities. The CA has two main responsibilities. First, it is responsible to issue the digital certificates that are used when implementing a public key infrastructure solution. This requires that the CA review information supplied by the client making the request for the digital certificate. The requester begins the process by providing the CA with a CSR, or Certificate Signing Request. The other main responsibility of the CA is the revocation of digital certificates that the CA has issued in the case of fraud on the requester's part, or when a security breach has occurred that involves the digital certificates that it has issued. The certificate authority creates, maintains, and publishes a list of revoked digital certificates to help ensure that the PKI process remains trusted. One method that is used to achieve this is through a certificate revocation list, also known as a CRL, which is periodically published to the certificate authority's website. Another method of achieving this is through the use of Online Certificate Status Protocol, or OCSP. OCSP is a protocol that uses HTTP to verify the status of a certificate directly with the certificate authority that issued that certificate. With that, let's move on to some additional public key infrastructure concepts. The first item is the recovery agent. A recovery agent is an individual with authorized access to the private key archive. Recovery agents are used within PKI to protect against the loss of a private key due to the key holder's absence. Private keys should be securely archived with access to the archive strictly limited. Due to the sensitivity of private keys, in most cases, the recovery process requires more than a single recovery agent in order to recover that private key. Then there is registration. It's a process that is typically used within an organization that has implemented its own PKI. The process is used to issue PKI certificates to employees or devices within the organization. The Registration Authority, or RA, has the responsibility for verifying an individual or device's need for a digital certificate, passing the request on to the CA if required. Trust models are used in PKI in order to build PKI relationships between different organizations. With PKI, trust can be created between two different certificate authorities so that each CA will implicitly trust the certificates issued by the other. This allows organizations to quickly validate digital certificates that each receives from the other entity. Trust models, also known as trust paths, are used to reduce the workload on PKI. Without the trust models, each implementation of PKI in the relationship would be required to issue digital certificates for the opposite party. Trust paths are also used to validate digital certificates issued by a subordinate CA back to the root certificate authority. That concludes this session on the Introduction to Public Key Infrastructure Part 2. We began with a discussion on certificate authority responsibilities, and we concluded with some additional public key infrastructure concepts. On behalf of PACE IT, thank you for watching this session, and I wish you the best of luck.